We're back? So let me know when you guys are ready, okay? Yay, more streaming. So with the new URL, things are back. But I wonder if people are still on Kahoot. Okay, if you're still on Kahoot, then stay there. Don't log out, don't refresh, do nothing, just continue. If you have been logged out, yeah, tough luck, but we still have the game pin on the page here. So if you go to kahoot.it, and the pin is 9934612, and then that should work, should get you back in. But then you lost all your scores, so ideally you just stay where you were. Shall we just finish it off quickly? Yeah? Okay, cool. MT, good luck.
We only have like 6 people on the stream right now.
Oh, 6 people.
Yeah.
Oh, that's not good. Then we'll just wait. And those are in the room probably.
Yeah, we're up to 30. It's rapidly increasing. I have no idea.
So if you were logged out, we kind of suddenly realized that we went offline. And after you commented that we got offline, and then we stopped the Kahoot immediately. So we have not continued in your absence. So if you were there with us, you can still play with us. Go to the game pin, yay. Now, here is this guy in this Kahoot called .waffle. And I think he should be disqualified as well, because I think he won the last 3 DKNOG Kahoots. Yeah. So this is a pro, so up 6 places. But he's not in the top 4 yet. He is playing from Sydney, yes. So that's interesting, that's a challenge. It's probably middle in the night there, right? Yeah. How are we doing with viewers? We okay? 43 only, okay.
Maybe we should just start it and...
Yeah, let's continue. Okay, cool. Yeah, let's continue. So the lag isn't that bad at the moment. I hit next. What does RPKI stand for? Now this should be an easy question, but from experience in our BGP course, I know this is not an easy question. See? This is what I mean. The first answer I gave was routing public key infrastructure. And still many people just, yeah, that sounds the most plausible. It has to do with routing, so go for that. The green one, routing private key infrastructure, is also not a correct one. All right, let's see what this did to the score. Oh la la. Not that much, actually, surprisingly. Okay, so you guys are still with us. That's cool. We go for the next one. Oh. How many Danish IPv6 prefixes are covered by a ROA? Yeah. 109. So this was a bit of a gambling round. People had no idea, basically. But at least only one person said they don't care about IPv6. Oh, that was you. Okay, cool. Yeah. Okay, let's see. Okay. Nico Duck. Ile? I think we're hitting the last question now, right? Let me see. Yeah. Oh. Next one. Oh no, two more. Can RPKI ROAs overlap? And you see people thinking, what does overlap even mean here? So the answer is yes. And with overlap, we mean that there can be a more specific, but there could also be exactly the same ROAS, but for a different AS number. You can generate two exactly the same ROAS. So you can play with all those dynamics. That is all possible. So yes, ROAS can overlap. Nee. Here. Okay. Okay. Still going on. What protocol can be used to download the RPKI data from the repositories? Yes, rsync, indeed, that's the most common one. But now more and more validators also allow RDP. So that's the RPKI Delta protocol. Okay, let's see. There he is, .waffle entered the top 5. Unbelievable, from Sydney. Good, okay. So that brings us to the final question. Oh. And now for something completely different. When was the DKNOG Foundation founded? And I hope I have it correct. On your website, oh, this is funny. On your website, it says 2019. Oh. On your own website,
right.
Alan.
This is technically correct, and as we all know, technically correct is the best kind of correct. Because this is the year that we've been officially registered as a foundation. We've been operating as a foundation 10 years before that.
Yeah, but the foundation was officially notary-wise founded. And that's what it says on your website. And everybody was wrong.
And that makes it an extremely good question. I like this.
So, what does this mean? Nobody had the right answer. Let's see what happened here. The chaos. Let the chaos commence. Yes. Net Ravenen, MT, and... Dun, 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 drum rolls. Guido Falfi, well done. And Dot Waffle and the 4 and 5. Okay, so, yay. If you're number 1, 2, and 3, and 4, yes, Dot Waffle, you're in. Then make sure you send your address details, so your home address details to Ellen, so I can ship you the stuff. That was it. Sorry for the hiccups. It was a trial to see if this would actually work online. We can say it kind of sort of does. I also heard some improvement, but I'm quite impressed with how you guys and girls and everybody did. So we are going to zoom out. I think it's a coffee break now, eh?
Absolutely. We're good over time because of technical hiccups and stuff like that, but we will take half an hour break now. And I'd just like to say that the winners can email dknog@dknog.dk. That is the easiest way to get their address to me. So the stream will continue again at 12:05. We really hope that everything plays well with us in terms of all the technical stuff that is involved. So let's give him a physical and virtual round of applause.
Yeah, thank you very much. And you still hear me okay? Just want to check.
Yes, we hear you, but we just need to change the slides.
Okay, just let me know when you want me to start.
We're ready, Bo. You can go ahead. Please go ahead, Bo.
Okay, thank you. Yeah, so my name is Bo Finnemann, systems architect with Cisco. And as Alan introduced, I'm going to talk about model-driven telemetry and give you an introduction to that subject. So I have prepared this agenda. First, I will give you an overview of model telemetry, a definition of what it is, and the technologies involved. Then a bit about MDT tools and some resources you can utilize for your further study, and give you a basis for your own introduction of MDT. Then I will present the analytics stack that you can use to visualize your data and make them useful. And we'll go through a sample use case. We ran one of our labs in our DKNOG, and we have captured some screenshots to visualize what it is we're talking about. So for the model-driven telemetry overview, what you see here is in network, we have the network elements to the left where data is created, and then to the right, we have our backend systems where we need to make data useful as a basis for our operations. And for collecting the data, for many years, we have used SNMP, syslog, and CLI, possibly other methods as well. SNMP is actually a well-defined standard with data models in MIPS, and it is data models that are organized hierarchically. But the big issue with SNMP really is scale. You can get data with a couple of minutes interval, but you quickly push the device too much if you go much further, and it gets overloaded. Also, SNMP is a polling system, so all the backend systems polls the network devices. Syslog is quite unstructured. Messages are proprietary for each network element, and they are written in plain English. And CLI is also very unstructured and not easily to handle for code. And we also have many changes in CLI between releases. You can do a lot with parsing and text mining to get structured data out of CLI and syslog, but it does not really scale. It's customized and it's complex. So that is why we want to move to use streaming telemetry, where we have a push paradigm, so which means we program the network elements to stream the data that we need for our use case or use cases. And there is one consistent way to access data, statistics, operational states, etc., and that is Yang data models. We have already used Yang data models for some years for configuration, so now we use them for both operations and configuration. Also, we can get a very high performance down to 10 seconds intervals or maybe lower. Telemetry involves multiple encodings and transport protocols available, and I will go through these a bit later. So just a definition of model-driven telemetry. I would define the telemetry as a process for collecting any useful operational data. And that is a very broad definition, which would include also SNMP and maybe even syslog. But model-driven telemetry, I would define as, to be very specific, Yang-based telemetry. You could argue that it could be based on any data modeling language, but since we have used Yang and standardized on Yang in the industry, we want to be specific and say it's Yang-based telemetry. And there we make sure that we can utilize the vast quantities of Yang models which are available in network devices today, and make them usable, make it easier to define the data you want to get and subscribe to it. Also, with data models, you can easily generate APIs, which we need everywhere these days. And again, same models are used for operations and configuration. There are a number of implementation options with model-driven telemetry, and I try to make an overview of it here. So for the data modeling language, as I said, that's Yang. There, as we see, no other options. It's a de facto standard. And then for the mode of operation, it can be dial in or dial out. So dial out is where the network is configured with, in its configuration, with what to send to who and at what interval. While with dial in, the collector, the network element just opens a specific port, and then a collector through that port can program the network element to what it should send with what interval. It can be either interval-driven telemetry or event-driven. So event-driven where, say, an interface goes down or changes state in some way that triggers a telemetry stream. For the transport protocol, what we basically can choose from is TCP, gRPC, and GNMI. And gRPC, with gRPC, you basically leverage the benefits of remote procedure call methods, and it also comes with TLS encryption, and it's part of the growing family of Google protocols for network management. And Google is also driving GNMI, which is used for dial-in, and it can be used for both operations and configuration, actually. For the encoding side, so you can encode data in JSON or using Google protocol buffers, which comes in two variants, compact or key value, also called self-describing GPB. JSON is completely string-based and thus easily to read, but also the least efficient on the wire, so uses the most bandwidth. Compact GPB is completely binary, so it uses a lot less bandwidth. And if you want to stream large amounts of data, compact GPB is recommended. And then for the encryption, so gRPC and GNMI has encryption enabled, so TLS enabled by default, but you can disable it. So a bit more about dial-in versus dial-out. So for dial-out, you have a bit broader flexibility in transport options. So you could, for example, use TCP, and you don't need to open any ports for inbound management traffic. And you can also use it or get leverage anycast or load balancing if you have multiple collectors. For dial-in, you have a single channel for configuration and telemetry, and you just configure a listening port on the router. So it's a very simple configuration on the router. You don't need any other telemetry configuration, and it's only dial-in is only available with gRPC and with DNMI, where the most simple configuration is with DNMI. But regardless of which side initiates the session, it is the router that streams the data to the collector. So it is always a push paradigm. So I want to highlight one very important aspect, that model-driven telemetry is really a great basis for closed-loop automation. And what is closed-loop automations? Today, the surveillance and monitoring of the network is to a large extent separate from the procedures to configure or to make changes in the network. And it's all very fragmented and linked together only by human technicians. We want to tie it all together in a closed loop using automation, machine learning, artificial intelligence. And this slide illustrates how closed loop automation works. So on the left, we have the telemetry side with the network elements and a collector. And then we have a network automation alerting service, which based on filtering and monitoring of the data in the collector can do alerts to the automation side, where it can trigger that a change automation component suggest changes that maybe you want them to be acknowledged by an operator, or some things can be done completely automatically by the change automation. It then instructs via an API the configuration deployment element to do the change in the network. And the configuration deployment component, it's a component that abstracts the complexity of the network. It knows about the network topology, the network elements, and their interfaces, APIs, and data models. So that's a really important point here, important use case for model-driven telemetry, that it to a much more extent enables closed-loop automation. Then for some tools and resources. So I want to start by showing a tool called Advanced NetConf Explorer, or ANX, which is an open source tool that we have made that can be used to explore Yang data models on a device. And you can actually download it from GitHub with the link shown here, and you can run it on Linux or a Docker container on your PC. It offers a number of great features like viewing Yang models, download all the Yang models, browse and search within models, show data, live data from the box, construct a netconf request and send it to the box and see what comes back, and show live streaming telemetry from the box. I will just show here two features, and one of them being here how we've searched on models with the word optics, and we can see here the model for optics operations and all the parameters that you can read through that node. And here another example where we show live data from the box. So it's interface stats, data, bytes received, bytes sent, and so on. Also, I want to make you aware of useful links for your further study. The Advanced NetConf Explorer, I just showed you that one. The Telemetry data mapper you can use for map data identifiers between SNMP, gRPC, NetConf, CLI, etc. And then you have the Yang model catalog and search engine and a Yang model collection on GitHub. In Cisco, we also have something called XR Docs, where there's a number of great blogs about telemetry. Furthermore, I would turn your attention to Cisco Live sessions, where you can log in with a cisco.com user ID, and you can see a lot of sessions about telemetry. And we also have the DKNOG, which offers you a lot of demos. So it's labs in the cloud that you can run yourself, and there are a number of labs as well on telemetry. Then for the analytics stack. So in order to make the data useful, you need an analytics stack to collect the data and store them in a database and make use of them. So this slide illustrates the so-called tick stack based on the Influx database portfolio. It's an open source stack. And first of all, you need a collector. And in this case, it's Telegraph. And Telegraph has several input plugins to get data from network elements and also output plugins to send data to a variety of databases. And Cisco has actually made input plugins for the Cisco OSs. So these plugins are available on GitHub as well. So you can download them if you want to use Telegraph with the Cisco devices. Then there's a time series database, which in this case is InfluxDB, and a time series database is different from your normal relational schema-based database. It's very fast, and it's based on key timestamps. Capacitor is a processing engine, and its primary role is to generate alerts. So it corresponds to the processing engine I showed in the slide with automation, with closed loop automation. So in this case, also capacitor can be used as a basis for closed loop automation use cases, where it will monitor data and process data, generate alerts, and trigger automation engines. And then we have here Chronograph, which is a visualization engine for making dashboards where you can see all your data visualized in graphs, etc. So this is, as I said, an open source stack. There are definitely also commercial stacks available, and Cisco also offers commercial stacks as well as others. And if a commercial stack can be relevant if you want a certain guarantee of scalability, stability, and a fully supported solution, and you don't want to use too much time putting things together yourself and being responsible for it yourself. But there are basically those two approaches to the stack. Okay, then we have, as I said, we ran a lab and captured some screenshots so to illustrate this sample use case. This use case is based on this telemetry stack. So we have a number of network elements or virtualized network elements, which are XR routers. And in this lab, pipeline is used as a collector instead of telegraph. It is also an open source collector. And here, Grafana is used for visualization, for the visualization dashboard instead of chronograph. And we have still InfluxDB as database and capacity for processing engine. In this lab, we're going to show packet rates and data rates and memory utilization. We're also going to show a BGP event and how that affects the data rate and packet rate graphs. First, here the configuration that we have made for this lab. So it's it's actually two parts. So there's a gRPC part, which would be a GNMI configuration with only a port, and we are not using that here. Then we also have the dial-out configuration, which is a telemetry model driven here, and that kind of configuration consists of a destination group where you configure who to send to and how. So here we define the encoding to be key value GPP, and we use TCP as protocol. And then we define a sensor group where we define what to send. You can see here CPU utilization, memory stats, interface counters, and data rates, and some BGP information. And then we make a subscription that ties together the sensor group or sensor groups and the destination group, and specifies the sample interval, which in this case is 1 second. Here is an example of telemetry data, and in this case, it's memory data, and you can see it's in a JSON format. So this slide just illustrates how you can easily, in Grafana, you can build graphs or configure graphs where you define what data model or what data model node, and the producer, which in this case is an iOS XR node, and an interface name, and then a data field, so exactly what data field it is you're looking at, in this case, the input data rate. So, and you can then build a number of graphs, and here we show 7 graphs. So we have input packet rate, we have it here with 30 seconds intervals. We have input packet rate with 1 second intervals. You can see it's a lot more granular. And we also have a data rate in kilobytes per second. And on the right side, we have output packet rate with 30-second interval, output packet rate with 1 second interval, just to show the difference. We have the memory utilization here. We have the output data rate. here is a slide that illustrates the difference between high intervals and low and short intervals, or long intervals and short intervals. So what we do is we generate some traffic with some ping packets here under A. So we generate 48,000 ping packets, as you can see here. So we generate some data. Then we analyze it here with 30 seconds interval, which we say is an emulation of SNMP, because that's maybe what we could do with SNMP on a good day. And then down here we have input packet rate with 1 second interval, which is what we maybe can do with the model-driven telemetry. And you can see the difference in granularity. Here, the packet rate is very much averaged out, so, and it only goes up to 3 kilopackets per second. While here, you see the spikes, and you can see it actually goes all the way up to 6 kilopackets per second. So it's much more informative and granular. And actually, the same goes for the output packet rate, exact same story, of course. Even here we go up to 7 kilopackets per second. So it's just to illustrate that importance of being able to with model-driven telemetry to stream with much shorter intervals and with much more granularity. Finally, here we have an example where we generate a BGP route flat. So we simply remove, at some point, we shut down a BGP peer. And you can see it in the bottom graph here, number C. So where the green is all the BGP routes learned, and the orange here is deleted BGP routes. And you see here in the input packet rate with 1 second intervals, you see a spike, because here around 10,000 BGP routes are being transferred on the wire. So that's why you see this spike here. With 30 seconds interval, it's not so much a spike because we average out things. And also you see here memory utilization, it drops as BGP routes are deleted. And basically you see also the spike here on the output packet rate. So it's just maybe a little bit artificial example, but how to show you what you can see with streaming telemetry. So finally, my time is running out, I can see. So for the summary, so model-driven telemetry is based on Yang data models, which we also use for configuration. It scales really great. I hope I convinced you about that. And we see model-driven telemetry as a good replacement for SNMP, syslog, CLI, and all the complex parsing and scripting that many people are doing in those areas. And MDT supports both event-based, interval-based, and actually also polling mode with GNMI. And very importantly, it's a great basis for closed-loop automation. As I showed, that you have really the basis for programmability and for doing the closed-loop automation. And then finally, there's lots of informations, blogs, training, labs, and tools available, which I showed you in the list of useful links. So I hope you can use all that information going forward. So that's all for me. So thanks a lot for your time, and Thanks for listening in.
Thank you very much, Bo. Let's see. Do we have any questions? The procedure is as it usually is. Indicate in the DKNOG 10 channel whether you want to ask a question, and we'll wait for you to type your question. No questions, it seems. Then I'm going to say thank you again, Bo. It's been really a pleasure to have you here remotely. It's been working very well. Thank you very much.
Thank you very much.
Excellent. So let's see where we are in the agenda now. Unfortunately, we're running 30 minutes behind the schedule. That's just how it is, unfortunately. And the next speaker up is Sebastian. And I'm just going to go up here and get his data started.
Back to original.
Yeah.
Hello everyone, I'm really excited to be here. I've been, like so many others, in a crisis management mode since late last night, and I just arrived half an hour ago. So this is actually kind of a break for me, seeing that we can still make things work, even though everything is different. Let's just say that. You might be staring at my slideshow, I assume. This is the commercial perspective of what I've been working on together with Maros and team for the last year or more. But this is actually not going to be about the commercial perspective. It's going to be a small talk about the journey we've been through and the lessons learned and what to be aware of in the SD-WAN market, where a lot of stuff is buzz and hard to decipher what is actually underneath the beautiful facade, so to say. If all goes well, I will take more of a commercial and lesson learned perspective, and then I actually have my colleague and architect Troels Foss with me remotely, and then he'll try to jump in on the last part of the presentation, just like you had Bo Finnemann on WebEx before. But let's see. So the setting is that I work for a large service provider, Scandinavian service provider called Global Connect, and in the past year or more, we have been working on introducing a SD-WAN offering to the market. And introducing is, of course, standard practice, going through first an RFI process, and then an RFQ process, and then a POC process with a lot of the major vendors, and this is basically where we started off. First off, and this is maybe the easy part, I assume that if you want to go out today, all of you, and buy a SD-WAN solution, you would focus on features. So I'm not going to go into deep with that. I just want to point out that when you go looking at features, there might be a lot of stuff that you would assume would be included in a SD-WAN solution. That is unfortunately not the true always. Some solutions, they only do basic tunnel encryption. And they don't actually include any of the routing features that we would normally expect of a simple WAN solution. So remember basics like basic routing, NATing, actually not an SD-WAN standard or not an implemented standard in all solutions, stateful firewall, redundancy features, multicast if that is important for you. And then again, we might think that SD-WAN is the modern technology or modern technology overall. But apparently IPv6 is also not a default in actually the majors, most of the major solutions. So watch out if that's important for you. For us, and I assume for a lot of you, SD-WAN and tunneling and private networks is all about security. I guess that's where it starts. And that's also where it continues into the SD-WAN world. So if you care about security, notice the details, so to say. Make sure that you have role-based access control for your interfaces. Make sure the tunnels are actually built in a proper way, that keys are rotated once in a while. A lot of solutions actually use the same encryption key forever until something breaks, and then they might try to reestablish also using that encryption key. But we had higher expectations of what we wanted in our solutions, so keep out for that. And then maybe the most obvious maybe user customer-facing feature is the new fancy firewalls. If you want to go next generation UTM, Unified Threat Management level firewalls, then that's also something that you need to get your head around. Oh, and yeah, and then there's something about the provisioning process. We'll get back to that later. Learning from the solutions we've looked at, there's a core SD-WAN feature set, but down the road you will, in the current market with the current solutions, probably experience, or we at least experienced, that we ended up having to choose between 3 peripheral feature sets. That means that's features that you might want included in the solution, but no vendor can actually provide them all in a feasible manner, at least, or a efficient manner. And so you have to choose between, in our experience, between either security or the SD-LAN, SD-Wi-Fi feature sets. That means integration of switch stacks and Wi-Fi access points, or the more data center focused feature sets. So yeah, that's basically it. Then a bit about the economics. SD-WAN economics is a bit different than we're used to in the service provider world. In service provider world, it's all about ports and cables and digging and IPs and stuff like that. But SD-WAN is intellectual property based, so to say. So it's a piece of software, and the economics around it is more like a piece of software that you would acquire. And that software is usually based or price based on features included, or feature tiers as we call it, or speed tiers. And especially the speed tiers is a nasty one, because for a lot of solutions it's actually consumption based. We are used to dealing with link speed cost, or line speed cost, or port speed cost. But here, a lot of the vendors, they actually try, and it's pretty difficult to get around being consumption-based, at least if you buy directly from vendors. So just be prepared for that perspective. Yeah. And I'm not going to say more of that. Then there's the different CPE schemes. Some vendors, they, let's just say some of the big ones that are very much into the hardware game, they try to tie together their software solution with their hardware stack. That has pros and cons. It means there's a hardware vendor login, but that also means there's a really good support. So some of the alternatives are, some are doing certified third-party hardware. That means they certify hardware from another vendor. And there you might have looser login, so you might have some selection of certified hardware, but it's also going to cost you on support and operational stability down the line. You will have to invest more in that and tinker around to make sure it works just as you expect to. And then there's, of course, the wet dream option, which comes with downsides, and that is that you can go out and procure your own hardware, build your own CPEs just as you would like. But then you're probably you have very little login, you can do whatever you want, but you're also gonna get no support, and we can already experience that might be a problem long term. Yeah. Oh yeah, and then last part of SD-WAN's wet dream, so to say, is the VNF service chaining, or NFV service chaining. I guess you all know about it. We have these concepts or dreams about being able to have just a hypervisor or orchestrator platform, and then we can deploy whatever branded or feature proven or security proven software stack on top. being it a firewall or a underlay optimization engine, forward error correction, packet duplication, maybe a cache, whatever. And right now we see that it's still very expensive to do. You have to, let's just say you have to be larger than us for this to be really economically viable. So don't make it, if time to market is, for example, important, don't have it as a plan A. Have maybe as a future roadmap thing to dig into that. Then some high-level differentiators. So when you have this combination of features you're looking for and these the economics of SD-WAN, then you end up having to look at some high-level differentiators that will ultimately lead you down your choice of solution or vendor or integration strategy. And some things to consider is, of course, existing synergies. If you have a lot of boxes already from one vendor that might support SD-WAN on top, just not deployed, then it might be, of course, important to you. Brand recognition, it's a thing. There might be some new players out there, but if the customers don't want it, if they want to see a specific brand and everything, that's something to consider. Then there's, of course, all the feature qualification thing. I already talked about that. The CP scheme. Following the CP scheme, that's the part where you need to decide on branded or certified or a white label. Following that, there's always the logistics and support issue, especially in these Corona days. Do the vendor have a nearshore stock, or are you going to get everything from China, and are they prepared for crisis situations? Very relevant in these times. And then, of course, raw performance. Some maybe more overlooked things that were important to us was the level of multi-tenancy. If you go out as a single enterprise, this might not be important for you, but somebody like us, a service provider, for us to efficiently scale, then we of course need some level of multi-tenancy. Then again, role integration. Does the platform support both the operator, the implementer perspective, and the customer role, or do you need to build another portal, a custom feature sets to support different roles in your whole value proposition? And then, of course, feature integration, and by that I actually mean that a lot of solutions out there have been developed over time or been assembled by mergers and acquisitions, and some of the solutions out there might on paper seem well, but when you actually dig into the interfaces and how things tie together, then they're actually not natively integrated. Then they're actually then you might have one interface for the firewall, and you might have another interface for user management and another interface for X feature, etc. And might not be a problem, but it is a thing out there. And then, yeah, I don't think I'm going into that, but for us, there's also, if we are a service provider, who are we competing with when we choose such a solution? Are we, by selecting a solution, are we actually competing with the direct to sales, a direct to customer market, or the system integrators, etc.? Yeah. And then, of course, local resource presence. And that is usually very closely tied to CP logistics and support. Yeah. So, a few on the conclusion slides. In reality, there is no acknowledged industry standards. There's huge differences in solutions out there, and there might be some standards. The MEF standards, the standards also tried or built together with the DKNOG consortium, but actually the vendor sales and the sales engineers, and actually you will also experience when you have to go out and sell it to your stakeholders, users, customers, your boss, then they don't actually care about the standards. So there is no standards to lean against or anything like that. So you need to decide and prioritize your requirements, and that's completely, it counts no matter your role or your segment or the features, use cases, how much money you got to come with it, you got to build it. It all comes down to, also control and risk management. Are you going to do a big CapEx investment and are ready to take a large risk, or do you want to try things out first, etc.? Yeah. And that's, of course, where you can go do it yourself. That's actually very viable today. if you have enough money and enough resources, or you can actually contact somebody like us. We might not provide the best solution for you or the perfect match for you. We hope so, but at least you can try it out first, or within limited scope and MRC based, so monthly recurring based instead of big capex investments. So that's definitely a consideration to make. Yeah. So point is, it's still somewhat new, higher risk technology. What we ended up doing was selecting, having to nail down our criteria. What did we think was important? And we selected a vendor called Versa Networks. They offered a full feature set, especially on a full WAN feature set, and especially on the security firewall feature set. They scored high. They had a CP scheme that we liked. They both had some branded options, but they also had some certified options. So we could go the safe way first, and then we could explore alternatives down the road. They provided proper performance. They had a high level of multi-tenancy and role and feature integration, because it's a solution built for SD-WAN from the ground up. Doesn't have like a lot of legacy heritage, so to say. And we ended up deciding that we would invest more in our own offering and weren't really interested in competing too much with the DIY solution, so to say. Yeah. And then of course price, always price. Yeah. But being honest about it, we also missed out on some things. We thought we knew about this, or we thought we knew that there was some stuff that would counter against us down the road after implementation, and we've certainly seen that in real life. We see a high demand for SD-LAN and SD-Wi-Fi. We also see a high demand for security, so we can't really say it was a wrong decision to down prioritize this, but that's definitely a thing, a part of the solution that we need to fix in the future or improve in the future. Existing synergies, we chose a vendor that the company has no prior relationship to. Brand recognition, basically most of you guys don't know Versa Networks. I can't blame them. I didn't know them 2 years ago. But that's of course going to be can be a challenge when going to market. CP logistics and support. Yes, they don't have any nearshore resources and engineers, etc. But we are working around it. We're not gonna fail because of these things. It's just lesson learned for you to know about. Then I'm gonna try and hand over to my colleague Troels. I'm gonna come back in the end for questions if you have any. Just step down for a second.
Hey guys, right. So I want to talk a bit about the deployment of our SD-WAN solution. First of all, a little bit about how we integrate with the rest of the company. So a big consideration is for us is time to market. So we've been set up as a separate division in the company. And that means we are independent of other business units, including technology and other product management. This gives us the opportunity to differentiate ourselves and be able to deliver on our points much quicker. It does have some downsides where you have to be diplomatic in some situations and also firm in others. But it's been working towards our benefits for now. And as a point as well, it gives us the possibility to put this up here. To reinvent our processes and take some chances as well. One important point to take away from all of this is to understand your integration points with all the legacy systems. We are, of course, dependent on the underlay network and how all other parts of the company work. So at some points we have to integrate, and that's cannot always be a smooth ride. You have to take into account people's both technical stuff, but also people's feelings. That's an important point. It's all, you work with people on both sides of the table. Yeah. So a little bit about the deployment and what it is we're actually building. So we're building SD-WAN, and SD-WAN comes with a lot of bus, and that was very clear that expectations. People had different ideas about what SD-WAN is, both externally in the company and internally in the group itself. And we have spent a lot of time trying to making sure that at least everybody internally in the group have the same expectations and are moving towards the same goals. As Sebastian mentioned, we chose a not very known vendor for our solution, and that has provided, from a technical perspective, limited documentation and knowledge base. So a lot of digging and understanding of how the solution and infrastructure and systems and software actually work have been down to actually trying stuff, testing stuff, looking into how to actually build everything. So talking about the expectations again, you have to demystify expectations. I think that's an important point. From a technical perspective, you have to look at it and see how the technology works, and then provide tangible results that people can actually work towards and with. And that goes both for the engineering team that we have in our group, but also for everybody that we integrate with. So that means delivery and product management, sales people, especially for sales, have to control the expectations and show them what we can actually do with the software and the service called SD-WAN. And then, the last point about all of this is the more you understand, separate the levels of complexity so that you make sure that sales get what they require or need for actually going forward with the product, developing it and selling it. And that product management also have that kind of idea. So trying to separate the complexity to make sure that people understand what it is we can actually do. And an important thing I keep reminding myself is people will always and forever understand technology on multiple levels. So for building an actually SD-WAN setup solution, it came back to infrastructure always will be infrastructure. So we built a physical data center with racks, power, and hardware, setting up a VMware or hypervisor solution using VMware, and everything in that setup is virtualized, as many of you will know. There's no fancy things going on in that. You will need a basic infrastructure setup for providing these kind of setups. Also for the network part, it's classical routing and switching and firewalling. I think this is an important point, that we are not building anything exotic or using exotic set of systems to set this up. It's all based on software that is deployed on classical infrastructure environment. So you need to keep your basics in check and making sure that all the infrastructure that you build are set up with best practice methods, as we are reliant on that. So the actual software-defined WAN, what is it and how are we utilizing it? So we have a central control plane. It manages everything. All the configuration and setup is done from the control plane or the controller. And that is hosted again on the infrastructure that I mentioned before. and then all the data plane is in the local branch or CPE devices. So that is where the decision power is, and where the packets are actually being looked at and checked for whatever kind of policies that we put on the traffic. So a very basic theme for SD-WAN is it's all based on tunnels. You will see this time and again where you look at it and you have to go into the configuration or the technical stuff, and you have to understand how the tunnels are created and set up, which kind of tunnels are used and how they're used. Specifically for Versa, they have a setup using IPsec and VTEP, so that's VLAN-based tunnels, and they also put in some proprietary tunnel systems or protocols for managing traffic. Yeah, an important point to understand how tunneling works for this kind of setup. The next point is about automation with the software, and I think this is a general thing for both for software-defined WAN or SDN in general, that this software imposes a lot of automation. This comes from first of all in the front end, so it's all when you look at it from the outside, it's all GUI based or provided with a very heavy API support for REST API. So that's like the first level of automation that you will encounter. A lot of stuff happens automatically when you start to configure stuff in a GUI. You can put a check mark in, and then it will create a ton of configuration in the backend. And that's the next point, that whatever you do or how you look at it, there is with the software a lot of automation happens that you are maybe or maybe not in control over. That goes for all the tunnel creation, virtual interface creation, routing, and MPLS setup. A lot of the SD-WAN solutions or setups will function with where routing or BGP setups are done very efficiently, and where community tags and other standard known technology is used, but just the setup and creation and configuration of it all is automated. So yeah, we are looking at a lot of routing instances. That is how they handle it specifically in Versa, our setup. So the takeaway from all of it is you need to understand the basic technology for all of this. You need to understand BGP and MPLS for setting it up and how the tunnels work. That is the ground basis technology used for all of this. What they've done is just put the software on top to automate a lot of the setup. So understand the basics, but especially understand your automation. With SD-WAN, a very hot topic is the zero-touch provisioning. So this have been, it's a very important point for us, because we as a service provider, we are focused on delivery of many solutions, and the more efficient the install and delivery process is, the better. We completely broke the existing logistics process for this, as they were not with SD-WAN. You also have a very hard dependency on authentication, and it's all of a sudden it's very dependent on this specific box that you have configured for the specific customer is installed at the specific location, which is some would say not very efficient, myself included. But trying to work around that and trying to work around how to actually do zero-touch provisioning, so you avoid this kind of dependency on the hardware and location and customer side, have been a challenge. So into that goes that it's a very common practice that a lot of these manual tasks is outsourced, and that does provide some flexibility, but it also doesn't mean that you're actually doing zero-touch provisioning. So what we are working with is mostly what we can call a one-touch provision. So you at all times have to configure the equipment at some point to actually make it get the staging configuration required. So a point about how we are trying to evolve or how we're trying to fix this is using DHCP first of all for getting the equipment online, and then that equipment will communicate with the vendor's staging and pre-staging setups. We are trying to develop a setup where we use very low bandwidth LTE links, so we are independent of the underlay. It's an important point for us and that goes for all of SD-WAN, that we are a underlay provider as well. So we always see the benefits of that, but we have to look at it from a perspective where we are underlay independent. And then as everything else also goes, we are building a new internal processes. You have to, as a company, you have to follow and making sure that the internal processes can follow along with the technical part of what you're building. So I wanted to talk a little bit about what it is. So SD-WAN provides. It's a new software and gives a lot of possibilities. It's a the feature complexity versus template. Simplicity here is an important point, for we are dealing with a lot of features. The software provides not just a simple router, a simple firewall, but it tries to combine everything from a router to a application aware box that can manipulate and handle traffic in many ways. And for us as a service provider, we also need to look at how do we deploy these solutions for many customers and not just one specific or special solution for everyone. So trying to find a good balance between the complexity and how to actually utilize templates is a big challenge and something we're working on. The software being where the holy grail means that we are hardware independent. It is a Linux-based software distribution, so and just with the specific IP software built on top. So as Sebastian also mentioned, we have provide some very flexible solutions with different hardware tiers, both for the branch devices, but also for the hosted part of the solution. So with the SD-WAN, it gives us the application and traffic steering. And there's a very big difference if you're actually doing quality of service or quality of experience. These concepts are not easy to get your head around. And I will say that understanding these is very important, the differences and how to best utilize them. It's very important both for building customer solutions, but also for distributing that information internally in your SD-WAN development group, both sales or and product management and other parties that you're working with. And then we also have a very large range of security functions that we, with the software, can deploy everywhere. With our specific setup, we, as Sebastian mentioned, focused on the security features being an important point. But you have to make sure that the hardware can utilize it and that we actually get what we want from it. Yeah, it's yes, no, maybe, and it depends on the customer. But we are actively working towards it being a possibility to support and implement wherever needed. Yeah, so it's a feature complexity versus how to actually simplify it for when you are providing managed services. Yeah, that is the point. Understand to limit yourself. Yeah.
Tools, I'm very sorry, but we have to cut you short here. We are running very much.
It's fine. Time. So this is actually just bonus, and I think Sebastian will take over if needed. But yeah, any questions? Anything? I think I'll go back to my last one here.
Yeah. We're running terribly much over time, and I think people are very, very hungry in the room. It's 1:10, and we haven't had lunch yet, so I think we can maybe take one question if there is something. Otherwise, I really suggest you reach out to Sebastian or Troels with the questions offline. I can provide you contacts if you need to.
I think both Christian and Sebastian will be there today if you're on site.
Yeah, absolutely. Good. Let's break for lunch then. Is that okay?
Thank you, guys.
Hello. Hello. This is Thomas. Hi. Perfect. I see a black screen, but this is not a problem for me. Your camera is on, I see, but yeah, that's fine. Okay, so we got Ellen here. Am I right? Okay, I have. Do you see my screen?
The question is, can you hear me?
I can hear you. Yes.
Good. We just had to get the right microphone through, and yes, we can see a presentation from you.
Okay, so the only issue for me is now I do have a, let's say, a feedback with a delay of 10 seconds, but I can handle that if I mute my loudspeaker.
Yeah,
And I. Oh, wait.
You should at least
I got
have
it.
only one audio source, right? So
No, I know what the issue was. I was in parallel in the YouTube stream, and the loudspeaker was not muted, so it was a delay of 10 seconds. Now so my voice is already on YouTube. Perfect.
yeah, good. So.
Perfect. Cool.
Excellent. So
Yeah.
allow me to introduce our next speaker, Thomas Weibler, who is with us from Germany in exile, and we're very happy to have him speak to us today. Give him a warm applause, whoever's left in the room.
Thank you very much, Alan, for the introduction. So, yes, first of all, welcome Copenhagen and the rest of the world on YouTube. I just mute my mobile phone because I thought I'm going to be on the stage at 2:30, but now we're a little bit ahead. That's great. So, I'm CTO and co-founder of Flex Optics, a company which is specialized in optical transceivers, especially for pluggable transceivers. I'm in the field of networking quite a long time, and I have seen, the complexity of networks changing in the last decade quite tremendously. And like this application we are running now here remotely, you can imagine there is a huge bandwidth need, and also not only for my application, but also when we distribute it via YouTube and all the network behind that. But comparing this with a network 10 years ago, the complexity to build such a network is in these days way more complex. And the same happened to transceivers, actually. So a decade ago, 10 gigabit transceivers were quite new, and when we compare it now in these days, 10 gigabit is definitely commodity. 100 gigabit is also there, and the latest and greatest technology is 400 gigabit. What I figured out is that also the complexity of these transceivers changed, and that's is my talk about. So what you see on the second slide there is I opened up two types of transceivers for you. The first one is a 10 gigabit transceiver, an SFP+, and on the bottom you see a 400 gigabit QSFP DD. And just off the pure size, you see it's bigger, but also inside of a 400 gigabit DD transceiver, 400 gigabit OSFP DD, there are new components introduced, like this big black chip here, which you see in the middle, or even those golden boxes. Those two, they are way bigger compared to those tubes on the 10 gigabit one. So I want to cover now especially those three components: the transmitter section, the receiver section, and we will look inside of these transmitters and receiver, and this ASIC, or this chip, the digital signal processor, the DSP, about what it does in a QSFP DD 400 gigabit transceiver and why is it needed. So let's start with the transmitter section. And in optical engineering, this transmitter is also called a TOSA. TOSA, this acronym stands for Transmitter Optical Subassembly. And you will see here on the screen why it is a subassembly. We have a golden box, which is empty currently. On the left side, there is an electrical connector. And we have to fill that empty golden box now with components, this subassembly. So this electrical connector connects the TOSA, the transmitter part, to the PCB of the transceiver itself, where the high-speed signal is coming from your switch to the PCB and then to the TOSA. Now, first of all, to generate light, we place 4 laser diodes, as we are talking about a 400 gigabit transceiver. So each laser diode is carrying 100 gigabit. This is for a single mode application. And we're going to multiplex those 4 wavelengths later on together. Those laser diodes have basically 2 characteristics. They take current to operate, and this current, this is the one thing. And the second thing is the light which they blur out is not focused. So let's first of all cover the current which those laser diodes take, and that the laser diodes will heat up. To do so, we need an electrical cooler to keep the laser diodes on a certain temperature level. And why is this important to have the laser diode on a certain temperature level? Well, if the temperature would fluctuate quite heavily, or if they would heat up too much, the wavelengths of the light which those laser diodes are going to emit would drift away. And in optical engineer or in an optical environment, we really want to keep laser diodes on a precise wavelength and not drifting it away. So we really need them on the right spot. So the electrical cooler is the part which takes care. And the second point about those laser diodes is that they emit light, but this is not focused. Like people who are wearing glasses, when they take off their glasses, they don't see properly, or everything is blurred. So when you wear glasses, the same we do with the laser, we put the laser glasses on, which are lenses, optical lenses. To give you a rough idea about those lenses have an XYZ dimension of 0.5 millimeter in all 3 dimensions, and they need to be placed in that spot precisely in X, Y, and Z, and then also fixed there. How to fix it? This is typically done with UV hardening glue. Now you can imagine that this UV hardening glue needs some certain characteristics that those lenses don't drift or shift over the lifetime of these optics. Because like after 5, 6, 7 years within the different temperature scenarios, if the glue would changes his behavior or his characteristic, the lenses could be out of focus. So that's a really, really important thing to keep those lenses there. So now we do have 4 wavelengths. All of them are focused, but still the receptacle is not, we can't insert it into the receptacle. This is what you see on the right top corner. You see the receptacle of your LC plug. So to get there, we need an optical multiplexer. And this is a 4-channel optical multiplexer, and typically people are aware of an optical multiplexer as a 1U chassis thing which you mount into your shelf, which has either 8 channels in CWDM or 20 channels of DWDM. Now this is a 4-channel MUX which we use there. How does this work? It's pretty much physics from high school. So we have a glass block, and on the top or on this final edge over there, on close to the receptacle, it's dotted glass. It's pretty much like a mirror. So the light beams are inserted into that glass block, and then they reflect on the counterpart side. And this glass block is a little bit angled, so also the light which is going to be reflected backwards has an angle, and that's how the zigzag which you see on the screen is going to be built at the end of the day. So all the 4 wavelengths will add up until that certain spot where it's going to be inserted into the receptacle. Now the 4 wavelengths are in the receptacle, and now we're going to hit the fiber. And on the other side of that fiber, there will be the receiver. The receiver itself is also called a ROSA, or a receiver optical subassembly. And again, it's an open box here, and it's empty. So we have to fill it again with components, and it's pretty much the other way around compared with the TOSA. First of all, we have an optical demultiplexer, which does separate all the 4 wavelengths again. With the speciality that at the final end, there are filters. So this green, blue, red, and yellow filter blocks there. So what those filters do, they only allow to pass a certain wavelength or a certain color. Like in this picture here, only the green light is passed by the green filter, and only the blue light is passed by the blue filter. And the other colors are bounced back and forward from top to the bottom in that filter block until they hit the appropriate filter. Now with that optical demultiplexer, we have the ability now to separate all the full wavelength again. And then again, we need optical lenses to focus the light, which is coming out of the filters and hitting a pin diode. This pin diode does the conversion from the optical light level to the electrical level. But yeah, I move on. So the pin diodes do convert the optical light level to the electrical level, but the signal, the amplitude which is coming out of that pin diode has a really, really low amplitude. It's really small. So the post-processing systems like the ASIC or the DSP later on, or the ASIC of your switch, he can't handle that signal because it's really too low. So typically, what you do then is that you boost it up, similar like at home when you listen to music and it's too quiet. You take an amplifier and you boost up the signal. The same happens in a ROSA. A huge block here is going to be added, is the amplifier, which does boost up the signal. One side story here is some of you might have made that experience with a very long reach transceiver up to 80 kilometers on 10 gigabit, for example. When you have connected this type of transceiver back to back with each other without any attenuation, you might have seen an interesting behavior in terms of the link came up, it stayed there for 5 seconds, and then it dropped, but it never came back up again. So yes, you have broken the transceiver basically, you have broken the ROSA, and inside of the ROSA you have broken the amplifier. So the laser, the pin diode still survived, but the amplifier got way too much current on the input and boosted it up too much and destroyed himself. So better attenuate there in such a circumstance. Okay, as I said at the beginning, we covered two components, the transmitter and the receiver. Now we come to the chip here. But first of all, before we come to the chip, we come to the production itself. About production, I could talk quite a lot in details, but I think an important thing to know is about testing, because that's also something we identified in network engineering. What is so important about testing? First, the overall goal, for example, is to have the traffic light on the right side, to have a green light there. And also for a transceiver part, to get a green light that it passed all the tests. Now, I took figures out of production, especially, and compared them. So you see here a graph. On the x-axis, you see a 10 gigabit transceiver, 100 gigabit, and a 400 gigabit transceiver. And on the y-axis, it's the timing. And there are basically 3 bars in that graph. The blue one is the assembly itself, the assembly time. And the green one, that's the really interesting one. That's the testing time of such a transceiver. And now, and the orange one is the combination of both of them. So interesting here is to see like a 10 gigabit transceiver assembly and testing, and for sure we do testing in batches, is roughly 8 minutes. And if you want to assemble a 400 gigabit transceiver, it's roughly 25 minutes, which is, well, it's a way more complex part. There is a growth in the assembly time. But when you look at the rise of the testing time, it's way steeper. The rise is way steeper. Looking at those overall 8 minutes for a 10 gigabit and ending up at 90 minutes just only for testing of a 400 gigabit, you see these are way different figures there. And the point is also, if you wanna optimize your production, there is way more margin to optimize is in testing instead of the assembly at the end of the day. And you can do this optimization in 2 ways. In a good way, when you do more automation in testing, also of the transceiver, or in a bad way, you just get rid of test cases. And then for sure, you will cut down the timing as well. The timing is important to have it as low as possible at the end of the day, because you occupy very expensive test equipment, and this brings up the cost and will be added to the transceiver which you purchased then. An example. I took an example for a test case is the temperature test. Like you test the transceiver on 0 degrees, and you measure the output performance of the 4 wavelengths, and you see that the green wavelength is wobbling away a little bit or drifting away a little bit. And then it will stabilize, and then you say, well, check, it passed the test, and the same we do with 70 degrees centigrade. But if you do add a second condition to it and say, well, instead of just looking at the pure temperature, we also look at the time, the picture would look totally different. So we would say, we start at room temperature, cool down the transceivers to 0 degree centigrade within 30 seconds, and give the transceiver another 20 seconds to get stabilized, then boost it up or heat it up to 70 degrees within 60 seconds, give the transceiver 20 seconds to get stabilized, all the 4 wavelengths, and then we still measure the output performance, but when the transceiver wouldn't be stabilized within 20 seconds, it's a failure part. So in the first test case I described, the transceiver would have passed the test. Now in the second test case, where we add the second condition of time into that test case, the same part would have failed. And there you see on which parameters you can tweak your test cases of such a component. So for sure, the overall goal, as I said at the beginning in the production, is to get the green light of the traffic light of the production of such a transceiver. Now, as already introduced at the beginning, I want to cover a little bit about the digital signal processor. Digital signal processor is newly introduced in 400 gigabit pluggable transceivers. It basically has 2 functions. The first one is take care about the encoding. This encoding and modulation, especially about PAM4, for example. I don't want to talk about PAM4 today. I don't want to talk about PAM4 and modulation. I do want to talk about the second function, which the digital signal processor covers. It is the forward error correction. So, forward error correction is nothing new, but it's new inside of a transceiver. Up to 10 gigabit, we had error detection. Like on your Ethernet frame, you have a 1500 byte frame, and at the end you have 4 bytes of a cycling redundancy check, the CRC check. With that 4 bytes, you can detect errors in that frame. In 100 gig and 400 gig, it's not sufficient any longer just to detect errors, but we also need the ability to correct errors. And that's the FEC, or the forward error correction, do. How does it work in principle? And I took an artificial example, which I will show before I describe the 100 gigabit setup. In 100 gigabit, the forward error correction is not inside of the transceiver. It's basically on your switching side. So the FEC inside of the switch does the encoding, brings it over to the transceiver, which is not shown here, and the transceiver brings it on the line, and on the other side the FEC decodes the signal again inside of the switch. This is in 400 gigabit. So how does this work in principle? And I took this, as already said, an artificial example. On the first step, my lorry, he has a payload. That's my FEC encoder. And this payload, and on the right side you see an excavator. He's the FEC decoder. So on the second step, the lorry hits the dodgy road, the bricks get somehow disordered on that platform of the lorry. And on the third step, the excavator, he brings back in order all the bricks on that platform of the lorry. Now you can imagine that the excavator, he takes a little bit time to get all the bricks back in order on that platform. The same also applies to a FEC inside your switch, and it takes time. So when you enable the FEC, or when the FEC is enabled, you will have a delay of roughly 100 nanoseconds to detect the error and also to correct it, roughly. How powerful is such a FEC? When you imagine a frame of 1,500 bytes, these are 12,000 bits. And when the errors are equally distributed all over that frame, we can correct 330 bits. When they are clustered at a certain spot, then the performance of the FEC goes down, and we only are able to correct 33 bits of that cluster within that frame. Right. So, as I described the 100 gigabit one, you can imagine the 400 gig looks a little bit different. In 400 gig, on the switching side, still the FEC is on the switch. This is the FEC 2 here. But there is also a FEC 1 inside of the transceiver. So how does it work? FEC 2 on the switch encodes the signal. This transceiver itself decodes the signal. So we covered the errors on the electrical traces between the ASIC and the transceiver. The FEC again encodes the signal, brings it on the fiber. On the counterpart interface, the FEC 1 decodes the signal. This is the optical path. Encodes it for the electrical path from the transceiver to the ASIC. And then the FEC 2 decodes it there again. And you might have experienced some interesting behaviors with the forward error correction. And I have basically two hints or tips there. The first one is, if you're seeing bit errors on your line, either 100 gig or later on a 400 gigabit link, doesn't matter, you better double check your FEC settings. So by default, depending on the media you're using, so let's say 100 gigabit SR4, which is a multi-mode interface, the switch should enable the FEC by default on both sides. Both switches should do this by default. Let's say 2 years ago, the implementation weren't that ruggedized of the operating system yet. So what happened there is some switches didn't turn it on, the FEC. And then you ended up with bit errors on your line. So you need to double check the FEC settings on both sides, enable it, and suddenly the bit errors might disappear. And the second thing is, and for example, this is maybe important to mention, a 100 gigabit LR4 application on single mode transmission 10 kilometer, the FEC is not required at all. So both switches typically shouldn't turn on the FEC. So the link should be bit error free without FEC in theory. And also, yeah, it works pretty well actually. The second point I want to make is, if you can't establish the link at all, you need to double check the amount of FECs which you have in line. In a 100 gigabit scenario, this is quite easy. You either have 0, 1, or 2. But in 400 gigabit, there will be 0, 1, 2, 3, or 4, because you have 2 FECs on the left side of your link and 2 FECs on the right side. And there is a whole combination possible which FECs are going to be enabled. Because when you have an unequal amount of FECs, like 3, your overall link wouldn't work at all. Because, like here in this example, the excavator, he can't handle the bobby car, and this is the same happens with your 400 gigabit link. Then, if you have 3 FECs, for example, in place, like on the left side the switch and the transceiver FEC, and on the right side only the transceiver FEC and not the switch FEC. Good. Finally, before I close up the presentation. I finished the presentation. I always try to give a little bit of an overview what will happen in 2020, especially on the pluggable transceiver market in terms of technology, and I don't want to talk about availability in these days. It's more about technology. I identified 3 interesting things there. The first one is 400 gig LR4 is the typical application, 10 kilometer doing 40 gigabit. And it's still not standardized yet which wavelengths are going to be used. Will it be CWDM4 wavelength grid, like 20 nanometer spacing of each wavelength to each other? Or will it be the well-known LAN-WDM 5 nanometer spacing? The LAN-WDM 5 nanometer spacing is known from 100 gigabit LR4. IEEE hasn't sorted it yet, and there are different tensions to go towards CWDM4 because it's cheaper to produce. But let's see where IEEE will move on. The second one is, I didn't expect it to come up, but they came up now. It's the 100 gig ER4 and ZR4. ZR4 doing 100 gig, 80 kilometers without any external amplification, straight out of the transceiver. Looking backwards in 2019 or mid-2019, I didn't expect something coming up like this because the final edge was something 25, 30 kilometers. Yes, you could tweak 30 kilometers transceivers up to, let's say, 35, 40 kilometers with some hex settings and also a higher bit error rate. But now we are at 80 kilometers straight out of a transceiver, which is pretty cool, and this works very well. And the third one is the 400 gig DR4, especially with SN plugs. Why do I mention that one? From the main idea, the 400 gig DR4 application is a new introduced standard for data center applications. So you have single mode transmission, eight fibers. Each of them is carrying, or each pair, so you have 4 pairs, is carrying 100 gigabit. But you can do a well-known breakout scenario, pretty much what we know from SR4 in multi-mode, but this is now in single mode. And why with that SN plug? Well, there are drawbacks because typically you would expect an MPO or MTP plug there. There are drawbacks of the MPO or MTP plug. So when you're in a breakout scenario, which you see on the right side with MPO, you typically have 2 ways to connect your links, either as shown on the right bottom corner, you have a straight link with 4 times 100 gigabit between 2 transceivers. Or you do a breakout like on the top right corner from a 400 gigabit transceiver out to 4 times 100 gigabit. These both scenarios are possible with MPO. And the big drawback is when you unplug the MPO, all the 4 lanes or all the 4 links, will go down. So if you want to maintain just a single link and you have to unplug the MPO, all the other 3 which don't have an issue will go down, or you will have a link loss. The great thing about the SN plug is it's actually, these are 4 plugs. So each plug is holding 2 ferrules, 2 fibers, and when you cluster them together like a block, you have 8 ferrules in a block, pretty much like an MPO. So it's a block of 4 plugs, each having 2 fibers, and you still have the possibility to release 2 fibers. So the other 6 fibers are still linked. So this is way more easier to maintain. And also, beside having a typical breakout scenario in the left top corner and also a straight connection on the left lower corner, you can do a full mesh. So you see here a full mesh with 8 400 gigabit transceivers, and each link is carrying 100 gigabit, and which is very, very great to do so. And on the top, in the middle here, in the middle section, we connected basically 3 switches, and each link of this transceiver then is doing 200 gigabit. And that's how this triangle is operated. So this DR4 is not only a pure 400 gigabit transceiver, it's also a 4 times 100 gigabit transceiver, or a 2 times 200 gigabit transceiver, or a 1 times 400 gigabit transceiver. In the single lambda environment, the 100 gigabit LR4, and you will miss here the 4. So it's not 100 gigabit LR4, that's the one which we know quite well. No, it's LR, let's say 1. And this 100 gigabit LR1 will be the linking partner to the DR4. So to build a scenario like here, when I go back to the SN and MPO comparison, on the breakout, For the DR4, you can use the 100 gigabit LR4 transceiver. It's going to be as form factor QSFP28, and they are available now. In DWDM, it's 40 gig up to 11 dB power budget and 25 gig as SFP28, also 11 dB power budget, which is available. All right, brings me to the end. And yeah, I'm happy to take questions from our side. There will be new challenges for sure to implement also especially the DSP into the Flexbox, to tweak the firmware on the DSP as well. Instead of only doing the microcontroller in these days, we also have to take care about the DSP. But that's a new challenge, and we are happy to take it. And now I'm happy to take questions. I'm also on Slack and can read the questions. If someone wants to type it, so I can read.
Excellent. So I have not seen many questions come in, but there was one, and there are a few that comes in now. So the first one was a clarifying question from something in the beginning, which was, what does PINTANT stand for? I think it must...
Can you type it in the Slack? I only understood pin tab. Is that right?
I will just type it in the direct message to you. It should have been pin diode, apparently. Is that autocorrect? What does pin diode?
Oh, it's
stand?
It's pin diode. Oh, that's. Sorry, it's an acronym. I don't know the shortcut for the pin. I have to look it up. Sorry. It's such an acronym which I use every day, but I never looked it up, to be honest.
It's fair enough. We will try to Google it.
Thank you very much for that, Tim. I will look it up, and I will post it in the channel. Thanks for that good question.
Good. There's also a question of what comes after 400 gig Ethernet. Will it be 2 times 400 gig? Or?
Yeah, I mean, when you look at the two form factors, I mean, I have talked now about QSFP-DD. There's the other one is the OSFP, and I'm pretty sure you're aware that Arista is pushing OSFP quite heavily, and OSFP has a big advantage when it comes to, let's say, newer technologies, because it's already ready to handle 800 gigabit. Just when you look at the sizing and also the electrical traces and the setup and also getting rid of the heat, the OSFP has some advantages there. So yes, the next step will be 800 gig. There is work ongoing on 800 gig. I haven't seen any terabit plugs and also haven't seen any work on terabit plugs so far, but the next step will be 800 gig and then terabit.
Okay, thank you very much, Thomas.
Thank you very much, and have a lovely day at home and in Copenhagen.
Thank you.
Thanks a lot.
All right. Well, I just need to quickly say that the program is a little bit of a moving target right now, and we are drifting insanely much, but as far as it seems right now, we'll end at 17:15 today. And before we go to the next speaker, we remember when we had this Kahoot quiz earlier today. The Australian-located .waffle was so kind to donate his prize to somebody in this room. Now, I don't really have a measure of giving it away, but I think somebody was on the top 5 list, and I think it was you. Weren't you? Yes. So here is a little gift for you. Good. Yeah. So next on the agenda is an item called Automate Yourself Within 6 months. And it's my pleasure to introduce Christian and Veit.
Okay. So I have to. I'm not very used to beginning. Okay, great. So thank you for having us today and for watching us as well. What we'd like to show to you is basically a result of the last 1.5 years we spent at Wobcom automating our core network and rebuilding our core network. And you might be familiar with this title because we already talked about this at the Neutral Interconnect Days and at the DKNOG. But if you think, oh no, not the same talk again, we have some updates. So this is version 2.0 of this talk. So stay tuned. And we'd like to just go through the talk as you may know it, but also give you an update about what changed and about the lessons we've learned. So it's basically a lessons learned of automating an ISP's core network. Just for you to know who we are the Wobcom, which is a city-owned or by the municipality-owned ISP in Wolfsburg, which is mainly known for Volkswagen as a car manufacturer. And that's basically it. We are doing currently fiber to the home for 68,000 households in Wolfsburg. We already connected about 30,000 households and are aiming at connecting everyone in Wolfsburg in the end to our fiber network. And yeah, today I have support from Veit, who's a freelance software developer, and we'll give you some more insight about the technical stuff we did. So I mentioned fiber. This is what happens if you say your marketing department that we need something like a mascot. If you need a mascot, this is Gary Glasfaser, which is the living fiber cable. So I mentioned we're doing a FTTH rollout. So we quite quickly discovered if you give people bandwidth, they start using it. And so we had to do all the new fancy stuff, 100 gigabit on every call link and 10 gigabit or even more, 80 gigabit for the aggregation layer and all that stuff. So we're currently doing a lot of work in the ground and trying to connect private customers to the internet, but of course we're also doing the classic business customer stuff. And if you start connecting a lot of customers to your network, then one thing comes up quite quickly, and that is automation. Because, well, everybody loves automation.
Right, and that's where software comes in, and that's where I come in. And apart from the mascot, this is a pretty run-of-the-mill situation. You have a relatively old network. You have decades of scripts that are used to provision all kinds of services. They're mostly written by ops people or networking engineers who might not have a background in how to write software, and that's all right. That's totally fine. But my job is then to come in and to clean these things up and make them a little bit better. And so what I need to make these things better is I basically need a diagram of the process. I need to make the whole process, not the scripts, encapsulate that into one technical thing. And so Wobcom drew a diagram for me and for themselves of how it was currently structured, and I think Christian has something to say about that.
Yeah, sure. So basically, we just looked at our basic doing and thought, okay, well, everything we do in the network is we're doing changes because we're doing ITIL and all this IT service stuff. So it was quite necessary for us to do to think about the process. And we thought, okay, if we want to automate, we need to draw a process and to see what are we actually doing and where are we interacting with a machine. And where are we maybe able to replace human-to-machine interaction with machine-to-machine interaction. So if you have a look at the diagram, you see the green ones and the blue ones. And the blue ones are things that are tasks you do in your head. So this is things a human has to do. And then there are the green ones, which is basically human-to-machine interaction. And if you start doing a change, then you, of course, plan it in your head, and then you create a ticket. Then you start doing it, which means that you are using SSH or Telnet or whatever to log into the router and then to configure something. And in the end, if the happy path is happening, then it's also updated within the ticket. And now we have to decide if we want to go the happy path or the bad path. The bad path is that we realize something got broke, and if we are lucky enough to be able to access the ticket system, then we can update the ticket, something broke. If things got really bad, we can't even do that. And then we have to decide to roll back. So we have to undo what we did, which means we have to SSH into the router again or use a serial cable and go to the data center to connect to the router. And then we have to find out the fitting no command in the Cisco or whatever shell and redo what we did. And in the end, we hopefully update the ticket and have to start over again. Or everything is working fine, then we just have to document what we did, or we forget to document what we did. Then we update the ticket or forget to update the ticket, and it stays open for years. And then in the end, we're done. So we came to this and thought, okay, what are we doing with this now? And then somebody was giving a talk at our company about digitalization or digitation. And there was this one sentence, which is, if you digitize a shitty process, then you have a shitty digital process. The sentence was said by Thorsten Dirks, which was the former CEO of Telefonica in Germany. Now he's CEO at Lufthansa, if I'm right. And this is exactly what described our situation. Because we realized quite quick that we already have a digital process. We need to digitize our processes. So we're talking about digital transformation, not about making something analog digital. And then we had a look around and looked what other companies did that had this challenge. And we quite quickly ended up with looking at Netflix. Because what they did basically was they were starting as a company that digitized human-to-machine interaction. And their human-to-machine interaction was, I was logging into their website and I was ordering a DVD, which was then brought to me by the post. And I took it, put it into my DVD player. I was able to watch the movie I've loaned from Netflix. And then after watching the movie, I put it back into the post and it was brought back to Netflix. And at some point, the bandwidth got bigger and internet got faster and more accessible for the people. And then what happened is they just replaced all this process of interacting with the DVD and the post office and all that stuff by clicking on their website on the movie, and you were instantly able to watch the movie. And we thought, okay, if we want to have a new service on a port, we instantly want to click on the port, say this service on this port, and then we want to have the service. This was what our goal was. And then we looked at the process and asked ourselves, okay, basically the one point where we are already clicking on the port and say, okay, this port has this service is the documentation. And as you see, the documentation is one of the last things we do. So we ended up with, okay, why the hell do we document after we did everything? Why don't we document it and use this information for getting the service to the network? And then Fight came back in, and we made a small workshop and came together with the company and built a complete new workflow, which was the basic template for all our technical doings afterwards.
And so this is the new process. And it looks a little streamlined, but also basically what happens is the documentation is the templating. It's the template for automation, and everything you write in there will be put in some way or another into the configuration. So if you tell me what IP address you want the device to have as management IP address, I can make it happen. You just have to tell me what you want. And so what we did was we surveyed the existing ecosystem of open source tooling because we like open source. We picked what we liked, and then we tried to push that as far as possible and went from there.
And what we quite quickly realized after looking at this, this process fundamentally changes the way your company works. So from that point on, where we had this process defined as the one process for configuration in our networks, this meant engineers don't provision services anymore. They had to get a new job, which is developing new services. So we are replacing every manual part of the daily engineering work by actually real engineering work, which means they have to go to the lab and test new services and find the best possible configuration for a service and optimize things and get things just better and more services available on the technical side, so that we can go to the customer and offer more and profit from the investment we've made into automation. And we basically just want now to show you how this looks like, just for you to get an impression about how we realized it. I have to say this is a quite old demo because there were a lot of movements in the past where we optimized things, which we will focus on afterwards. So just to give you an idea how it looks like, this is basically our starting point. I just SSH into one of our switches. And I will now just have a look at a port. And my target in this demo is to show you just how to configure a VLAN, which maybe in this example it will deliver a service. So I go to Netbox. Netbox is our tool for interacting. This means I create a new change in Netbox. This is something we implemented into it additionally, and this is the reason why we also have to maintain a fork. So I now say, okay, I create a change. I define a change title, say my implications of it, and say also what will happen if we don't do this, what I'm going to do. And also we have to give some category information or say if it's an emergency change which would cause that it will be immediately rolled out to the network. And yeah, after this I say create change, and from that point on I'm allowed to change things in the documentation. Before that I wasn't able to change anything in Netbox. So now I go to my leaf switch, for example, and select one of my ports. You see all the ports of the devices, the virtual ones and the physical ones are listed, and now I go to the switch interface and say, okay, it has a parent, which is the bridge that is necessary for switching, and then I go and say, okay, I will now add a VLAN on it, and say, okay, this will be access VLAN, for example, 13. And I say, okay, update it, and just update my documentation. I might want also to do a BPDU filter or a BPDU guard on the port, whatever is necessary. And after I'm done with that, I'm ending my change, and now I get a small summary about what I've changed inside Netbox, and I can check it, and if it's okay, I say accept. And what now happens is that we are going to export a immediate YAML format out of Netbox into GitLab. So now we're done, and now we have created the change. And what I now want to show you is the switch port we configured. So we just keep the link for afterwards, and are having a look at the switch port we configured. And as you see, there's no VLAN on that port anymore. And the reason is we want to make sure that the documentation always is the real world state. And the documentation has not to contain a target state, it has to contain the current state. So we are now switching over to GitLab and having a look at, well, I actually have somehow managed to skip one slide. Yeah, so I'm not sure what is happening right now. Okay. Just, okay. I have already thought about what might happen if I am exporting something from Keynote to PowerPoint. But let's make sure, yeah, okay. So this is GitLab. And inside GitLab, we created with the data out of Netbox a merge request. This merge request contains all the information that I've given into the ticket. And it also contains 2 pipelines, which are made through the GitLab CI feature. And so what we're basically doing is, after creating the merge request, we are having one pipeline running, and the pipeline is doing checks. So it's just checking, are there valid IP addresses in it? Do I have forgotten to do something in the configuration syntax? Are there tags missing that might be necessary for a certain scenario or something like that? So we are basically checking everything. And if the pipeline is green, then you are allowed to merge the merge request into the master, which means that we are merging all the configuration variables we have exported out of Netbox into the master branch of our network repository. And this causes then afterwards to trigger a second pipeline, and this pipeline is going with Ansible through the whole network and pushing the new templated and generated configuration to the devices, and afterwards reloads the interfaces of the devices so that the configuration becomes running. And the last job of this pipeline is to go into the Netbox and activate the configuration that we did in the documentation. So from the point on where the pipeline has finished, you are able to see also inside Netbox that now there's a VLAN configured on that port, for example. That means if we just go manual on, then the pipeline is running through, and the pipeline at some point finishes, and after it's finished, the last job is to do the callback. And now after the callback, we just can switch over to Netbox, and now you see that there's a VLAN configured on that port, which wasn't configured before, which you were not able to see before. So the last thing we do is to update the documentation. And this actually means that we can make sure if you look something up in the documentation, it's always the thing that is currently running in the network. And this is, in our opinion, very important for things like debugging or something else. And now we want just to give you a short overview about the technical parts of all this. So, yeah.
Cool. And for those of you who have seen this talk before, this is also where we're going to talk a little bit about lessons learned and what has changed since the last time that you might have seen this talk. If you haven't seen the talk before, then this is also entertaining because we're also going to recap everything. So I'm going to show you what's behind all of this. And as I said before, what we wanted to do is reuse as much as possible so that we get features for free. That's why we're using GitLab and Netbox and so on, and it didn't build our own CRM. And what I'm going to do is I'm going to go through the components one by one, and then we're going to stick it all back together, and the lessons learned will be revealed on the way. So we use Netbox, as you saw, as our source of truth. It's a quite convenient tool. As you saw in the demo, though, we had to change a few things to make our workflow possible, and thus we have an internal fork of Netbox, which means that we have a changed version running. We added change management based on ITIL. This needed to be in Netbox for us because we wanted to start everything by documenting, but we also didn't want the documentation to not have an accurate state of the world in it. All the changes that we added are in their own modules, and we try to change as few existing code, make as few changes to existing code as possible, which did make a few things more complex, like making the YAML, creating the YAML out of models and so on. But it does buy us the ability to get back the changes from mainline. Right. So this is what change management looked like. It looked in the demo. It looked even different because it wasn't aligned correctly and so on. And at one point, I actually took the time to fix some CSS, which is always fun. And then, but right now, what it looks like is like this. The tickets are, instead of creating the tickets as we did here in Netbox, the tickets should be and are managed by our ticket system. And what Netbox does is check for their existence and check for the status and do all of that. But that way we have a better separation of concerns because the ticket system is actually better at managing tickets than we could be. And that should be obvious, but it wasn't to us when you build it. We just built it and we said, okay, I want to click in Netbox and I want to do this and I want to have everything in one thing. It turned out, well, that's not a great idea, but oh well.
And I have to add, of course, we are humans, and this meant that you make mistakes when you do a change in Netbox. And sometimes you just want to add something like a tag you might have forgotten or another port you might have forgotten to a change you are doing. So we had to find somehow a convenient way to put together one single change of several edits in the Netbox. And the most convenient and easy way was to be able to refer just to a ticket system change and then to be able to access the editings that have been made inside Netbox referring to that change.
Exactly. Yeah. There are other reasons why you would want that. I'm not gonna go into them right now. If you want to hear more about it, I have a lot. I have a lot to say about this. But what I also want to emphasize is, with if Netbox had a plugin system, we wouldn't need to do this. And we tried building our own plugin system to Netbox, and it worked. And we tried to merge it back into mainline to no avail. The people decided that's out of scope. Then they decided that's in scope, but they want to do their own thing, which is fine. There is now an open issue for having plugins, supporting plugins. If you want to help the community out, if you think you need this, give issue number 3351 some love. It's right in there. If you scan that QR code, you can comment or whatever. Cool. The next thing that we have in our pipeline is GitLab. We write all of our YAML into GitLab, and we use it for the current state of our infrastructure. We also use it to develop our code and so on. So it's quite convenient. Because Git is great and GitLab has beautiful diffing mechanisms, reviewing changes is fairly simple. You can read through that kind of stuff without knowing the code that deploys them. You just have to know, okay, what is a CLAG, and does that ID make sense? And then you can review things without knowing the code. We use a lot of other features in GitLab, like issues, merge requests. We track our code and our infrastructure that way, and it's been pretty good. GitLab is really a solid tool. We also do things like enforcing approvals, so that someone has to approve a thing before it can be rolled out in production. It's a paid feature. Using approvals, we can also do that via the API, so that we can get the status from the ticket system back into GitLab. We also tag and label and do everything to like automatic merge requests. That makes it easy to get their state, to filter by state, and that kind of stuff, so that they don't get lost. We use the GitLab Runner, which is a CI or a CD tool for those of you who know software development. We use it to verify and provision our changes, which is a little different than most people use it, but that's okay. When the merge request first gets submitted, we verify it with the check stages. You saw that already. Once it's been okayed and merged, the runner deploys it into production, and we call it a day. We call it the pipeline. From a bird's eye perspective, all it does really is set things up, talk to a bunch of services, and then run a whole lot of Ansible. And we didn't have to change GitLab in any way, it just works. You have to configure all of your pipelines, of course, that's to be expected. An important step here is the Ansible check run, which checks whether all of our roles can sensibly execute with the data that we were provided by Netbox, which makes sense. And then that's the actual provisioning. It does the same things. It checks things again, just to make sure that nothing has changed. And it does the actual production run of these roles. There are 2 roles in that pipeline that need manual acknowledgement, Cumulus and DNS, so that we can time them. So if we have a maintenance window, our DNS only gets touched when we really want it. We here got an error by validate cabling, which is allowed to fail, so that's great. So you can develop roles and you can have them in there in VIP in work in progress and just track them like that and see whether they actually run. So at this point, validate cabling was still in a work in progress. But as you see, like, these are huge pipelines, right? And so at one point we realized that instead of doing it that way, we might actually use use a little less in our pipeline, because some things change more often than others. Some things, like monitoring, have a different release cycle, and they shouldn't be part of the deployment process. You don't want to touch your monitoring for all devices every time you update something in one device. We realized that we didn't need to do all that work every time. Again, should be obvious, but the simplicity of having one pipeline was tempting until we actually had all of these things running. So those are things that you learn, and sometimes sometimes you think you're going the obvious route, and then you realize that you're going down the obviously wrong route, and it might have made it into production by that point. Cool. Apart from a few custom Python scripts, we use vanilla Ansible for all of our provision tasks, and there's nothing magical here. We just describe what you usually would do, like configuration files and so on, and fill in the blanks with the YAML we get from Netbox. It's very basic, which also means it's pretty extensible. You can do that with any kind of configuration, not just one kind. And adding new steps for new devices is as simple as adding a new playbook for Ansible or roles, or maybe a step in the pipeline, and then you're done. As I said, we also provision our monitoring and so on, not through the pipeline anymore, but through a different route, but it's basically the same process.
It's also a pipeline.
It's also a pipeline. It's a different pipeline, though. Yes. But again, there we realized that might not be super, because as we scaled, Ansible got really slow. The templating is not the fastest. And so what we did is we wrote a custom fast Haskell tool that does our templating, because Ansible template, the engine is just very slow. We reduced the running time of our whole deployment process tremendously just by doing that. And what I want to emphasize at this point, though, is that our engine isn't faster because we're smart and the Ansible people aren't, but because we needed a less general tool. Ansible is a templating engine that can do anything for you. It has a template engine that does anything for you. we needed less generality. We needed less scope, and you can make things go really fast by reducing scope. No fancy logo for this set of components. It's all the things that help around the pipeline, and they're all really important, but none of them were a big pain to add. We added Prometheus, a Grafana, we have node exporters, we do climate control with Prometheus. It's really weird. We also have the ticket system, Topdesk, which does our change management. It's a little enterprisey, but it has an API, and we wrote a simple API wrapper in Python to be able to open tickets from within the pipeline and so on, and pull their status. We have a surveyor that checks these tickets every once in a while, and it tells GitLab when a change has been accepted and so on. It's really fairly simple as well. We use Mimir as well, which is an in-house tool. It's open source on our GitLab. It wraps SSH sessions in HTTP, so you don't have to deal with different SSH implementations and their bugs. You just send a command to a REST endpoint, and there is a service that will talk to the device and will figure out what kind of device is it and how do I have to talk to it, because it differs a lot from vendor to vendor. And if you write tools in Python, you will quickly realize that there is a library called PairMyco or NetMyco. Those are Python libraries that wrap that and do all kinds of fancy things to figure out what shell they're on. And so basically we use that. Cool. Again, that used to be true. Now the service is inside the pipeline. Well, all of the alert managers, all of the monitoring, all of that is gone. It's in a different pipeline. What is still in there is our configuration compiler, which is Odin, the thing in the bottom. And we just let it and Ansible do a lion's share of the work. Odin generates configurations, Ansible just pushes it onto the servers, and all of the other things are outside of that pipeline and in different pipelines. And that makes things much more manageable because things have different release cycles, which is good. In the end, all we wanted was to stop caring about hardware so much. We wanted to make switching hardware really, really simple, because it's always been a big fight whenever you introduce new hardware and people have to learn a new shell and a new set of commands and whatever. And it doesn't really, honestly, it shouldn't matter. It should be as simple as switching software. So not totally easy, but only a little work required. So that meant for us that we had to build a whole bunch of abstractions like Mimir and Odin and so on that make it easy to change bits in our pipeline. But thus far, that has been fairly successful, with a few bumps in the road and with a few things that you have to learn along the way and switch out. So I guess the question is now, what did we build? What's the bottom line? And I'm going to hand over to Chris again to tell you that part.
Well, we basically built in the end a very simple and extensible tool to automate our change workflow and the human-to-machine interactions. We already found out that our criteria to build it in the most flexible way has been proven by the capability to redesign the whole workflow and the pipeline and its components in production without big steps to take. So we've been easily able to adapt it to the reality of our business and to get quicker and to get more efficient and to less worry about somebody who's just forgetting to type the add or the remove command in the end of the VLAN of the port. So it turned out that our approach to say, okay, we want to be like Netflix, so click yourself the service you want to have and get the service, was a good choice. It also showed us that it made it very easy for us to evolve and to just develop our started MVP project to something that is capable of fully running an ISP network. And that approach was a good choice. And now, of course, we are trying to make it quicker, to make it easier, to add more services, and to make everything just a little bit smarter. And also, we are happy that we are able to use the most of the work time of our employees in the engineering team to do actual engineering and not to provision services anymore by logging into a router and doing some configs on some ports. And one very, 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 very important thing is open source for us. We believe in open source, and we're not very good at it. So this is something Veit can definitely tell you more about it.
Yeah. As always, I mean, you've seen all this stuff. Some of the stuff is really easily generalizable, and we put it online, and some things need to stay custom, such as life. It's just how it is. But what we get and what we want to have in the end is we want to build things on top of open source so that we have an incentive to publish our fixes, to help the community, to contribute back. So we contributed back to Netbox a couple of times. We contributed back to other libraries and exporters that we use. We now publish a bunch of our Prometheus exporters that we wrote ourselves. I think next up is a Slack exporter. So if you really want to know how many people are in your Slack and how many custom emojis your team has, and you want that in a fancy dashboard, because that's what everyone needs, then you can get that from us now. Yeah. So like the bottom line is, if you miss something, if you think that there is a big component that we talked about today as missing, you might want to talk to us later.
So thank you, everyone. And now we'd be open to answer questions if there are any.
All right. First of all, thank you very much. It's been really nice having this talk. We have a few questions, not many. One of them got a little lost in the backlog here. Let's see. Yeah. Do you have any ways of detecting it whether a change will lock you out of the device?
That's a good question, actually. I have to look at the engineers in the back, and they are shaking their heads, I guess. So no, I don't think that we are able to detect if a change will lock us out of a device, but that's something we eliminated by having a fully out-of-band management network, so there's no in-band management currently running at the components that are used in the automation. So at the moment, there's no point if you're not configuring out-of-band ports and are removing the config from them, then yeah, we eliminated it by having out-of-band access to the devices in the worst case with a terminal server.
Excellent.
I would like to say that this is hard to do generally. There are some things that we can detect in the check pipeline, and like if there are new things that we figure out, hey, we could add a new check here, we can just add that, and it's relatively simple and relatively little work. But sanitizing the whole config for everything is something that at least I can't do, and I don't think our team can do.
Okay. Next question comes from Søren. He wants to know if you have looked into simulating changes as part of the pipeline.
Yes, we have. And it's a very, very special topic because we did this, especially in the beginning of the project. Most of our development work has happened virtual. So as part of the pipeline, we spawned using those. So we are using Cumulus Linux on our switching hardware, and they provide a very nice Vagrant framework and tooling to just spawn your whole infrastructure with one file as a Vagrant setup. And we did this, and we developed using this, and then we found out that it's not simulating the switching ASIC in the proper way. So there were a lot of things that were marked as, okay, it would cause a downtime or something like that, that is not causing a downtime on the real switching ASIC. Or in another way, some things on the ASIC will cause a downtime, but in virtual, they are just happening instantly. So in the end, we decided not to do this in the pipeline at the moment. I mean, if there will be someday maybe more possibilities to simulate switching ASICs in a better way, but at the moment it's not very profitable for us to do this because it's creating a lot of false positives.
Got it. There's a final question here from Gordon. He says, what are your thoughts about displaying desired state versus current state in a system like Netbox? How do you handle concurrent changes if the changes do not show up in Netbox until the merge request is merged?
Yeah, that was a big topic. God, we spent so much time on that. And thinking about that, the concurrent changes and so on. Something you might not have seen because you only looked at the change form for a brief moment, but there was this thing, let me pull that up real quick, depends on way in the bottom. And you can say this, so those are in the testing and they don't have titles, but what it usually would do is like you have a change number and then you have a change title. And you can say this change depends on that other change, which also isn't deployed yet. And that was our like halfway fix until we realized that a lot of this can be eliminated by just making the pipeline much faster, making the turnaround much faster, so that people can document and think about the changes. And that's also one of the reasons why we decoupled creating the ticket from creating the change, so that you can create the ticket, you can talk about it, then change Netbox, then deploy that thing, deploy it quickly, and then hopefully you get a quicker turnaround and less concurrent changes happen. Before that, when we had all of that together, like the quickest turnaround that you get is an hour, maybe 2 hours, and that really doesn't scale. So now we brought it down to a few minutes, which is much better. And
of course, this is a mitigation of the problem, not a solution for the problem. So in the end, of course, we're aiming at having a netbox which is capable of displaying target states and current states. So it's an idea we already have talked a lot about it, and there are a lot of ideas how to implement it. But that's a topic that really strongly depends on the plugin system, because we decided not to do any further netbox development in an extensive way anymore till they have released the plugin system, because we wasted a lot of time developing things that broke after the netbox guys made some mainline things. And so with plugins, we won't need to anymore. So yeah, give the issue some love and push the guys a little bit more that it will come up soon.
We're also very thankful for the project. We don't want to rip on like the maintainers right now and like put them under pressure. Jeremy is doing tremendous work. He's doing it almost all alone. So like he's doing great work. I just want to make sure that doesn't get lost. Like there is no hard feelings. We love the project. We contribute back to it. But also we have our own needs and our own agenda, so to say.
Excellent. Thank you very much.
You're welcome.
And as I mentioned before, the program is a moving target. We have made some further adjustments to it, and we will now have a break. The break will be until 15:30. And when we come back, we will hear about the Rift protocol. So we'll be back at 15:30.
large data center customers and cloud providers. And so we're trying to solve their specific issues, if you want to say. And one of the things we're working on together with others in IETF is a new protocol for the data center, which is called routing in fat trees, or in short, Rift. So very briefly on the agenda, I want to start with why are we working on this new protocol? What issues are we seeing and trying to solve? Then we'll go into what is Rift, what some of the basic concepts. We'll touch on some of the advantages. And I have a very brief update on where we are in IETF currently, and can mention some implementations. Why do we need a new protocol in IP Fabric or in the data center? If you look at what is happening in the data center, there's a few interesting trends going on, and some of them were already mentioned in one of the previous presentations. Bandwidth consumption is massively growing. A lot of our customers, what I'm seeing is that they are pushing even more traffic within the data center than outside of the data center. In some cases, even up to 80% of traffic is inside the data center. And so although a lot of enterprises especially are moving into cloud, you can imagine that, well, cloud is just someone else's computer in a data center. The bandwidth needs within the data center are exploding, if you want to say. Especially if you focus on hyperscalers and very large data centers, you see that they don't just use IP fabrics within the data center for server farms, but the trend going on now is to move away from big chassis to what we call scale-out architecture. So even in Metro and the WAN, we see that routers are now being built in a disaggregated or a distributed fashion. So in other words, we see customers building, for example, peering routers with 1U boxes connected to an IP fabric. And so the driver, one of the biggest drivers behind that is that a lot of these large data centers and hyperscalers are more interested in specific features of a chipset than that they're interested in proprietary or so they're looking for a how do we say that, generic box or chipset they can use within their data center, sort of independent of who builds the box around it. So a lot of these customers are looking into features, but also if you do, for example, power calculations, if you put a big chassis in your data center and you don't use the full capacity, you can imagine that it's not that power efficient, right? Because the power supplies are built to power the whole chassis, but if you only put in like 2 or 3 line cards where you could put in 16, you're using much more power than you could. So a lot of these data centers are looking into building scale out instead of scale up. Some other trends we're seeing is L3 forwarding is the new L2. So we're sort of preaching and now seeing that we want to get rid of L2 wherever possible. So especially in DCI, data center interconnect, you would not want to run L2 because of all the typical L2 issues as DCI. So a lot of these networks are still using link state protocols. And they have advantages, right? So one of the biggest advantages is that conversion is really fast. There's probably, well, not much protocols that can do conversion faster. The problem is that each node sort of has its own version, its own view of the whole network, the whole topology. And that does work pretty well in a small scale. However, if you imagine a hyperscaler having a data center with a few thousand switches, that can become a problem. Not only because you need, for example, large FIP scale or RIP scale, but also because of the fluting, right? If something changes within the network, every node needs to get that update. And because of all those updates being sent around, in majority of cases, the newest version of an update wins, which could be handy, but not always if you want to do, for example, load balancing within the network. Yeah, so and then the other alternative, if you want to say, is a distance or path vector protocol, where you see some of the issues, the prefixes being advertised around the network. Every node within the network needs to calculate a best path and re-advertises that route or path to other nodes. So it's also called routing by rumor. You can imagine that's at least slower compared to a link state protocol routing. And there's a lot of other issues like loop prevention. If you run iBGP or eBGP, you need allow ASIN, or it's really easy to create loops. So that's not ideal as well. So what we've did as an industry over the past few years is we sort of created a lot of bandages, and especially if you look at the larger DC fabrics, they basically all use eBGP as the de facto for IGP. But as mentioned, it's really easy to create loops, allow ASIN, allow own ASIN. Sorry. We've introduced tweaks like add path. But again, if you build a very large fabric, you run out of private ASNs. And so there's a lot of sort of ways to, or bandages we put around it. And on the other hand, we see customers running ISIS, for example, as well as with BGP bandages to sort of tweak ISIS to be able to build your IP fabric underlay. The problem with ISIS is that, and that is solved in different work in IETF as well, but that in general, there's a lot of overhead from the protocol itself. So what are the requirements? This is maybe not a full, complete overview, but it sort of shows the differences between what does BGP solve or cannot solve, what does ISIS solve or cannot solve, and on the right side, some of the advantages of this new protocol, Rift. You see on the left side a lot of issues that are sort of being taken care of by modifying BGP or ISIS. But with Rift, it sort of started from the other way around. So first, they came up with a list of issues they wanted to solve and then build a protocol around it instead of the other way around. And you see there's advantages and disadvantages also for Rift. It is maybe not the simplest to implement initially, because it's of course a learning curve. New protocol works different than what we're used to, and we'll get to how it actually works. So how does it work? Basically, if you break it down, it comes down to that it's a link state protocol northbound and a distance vector protocol southbound. So what does that mean? If you look at from the bottom of the fabric, so the level 0 in this case, those boxes that could be switches or servers connected to the fabric, they only have default routes northbound. So they have no knowledge at all about the rest of the network. And the good thing is, and the reason for doing that is that you can use really cheap silicon for those boxes. And so the other way around, if you look at the green and the red boxes in this picture, they know only the routes which are southbound of them, right? So even the green boxes, they know the more specific routes of the blue boxes, but up they only see a default route. And so this scales very well. Here you see just 3 levels, but this would scale up to 5 or maybe even 7 layers if needed. Where if you would have a link failure or node failure, we'll get to that in one of the later slides, the protocol automatically disaggregates prefixes. So that is one thing that is, and you only need to disaggregate, and that's interesting, 1 level up. So even a disaggregated prefix doesn't have to be known by the whole fabric. So let's zoom into some of the other advantages and to continue on the disaggregation. So in this picture, again, we have a 3-level fabric where P1 on the right side, downside of the picture, is connected to the gray boxes. Then they are connected to the green boxes A and B, and the top of the fabric is red A and B. And you see that B is missing links towards the green boxes. So now imagine that if you're connected to the left side of this fabric, and B would still originate a default route down in the fabric, then B would obviously black hole traffic for P1. So what happens is that as soon as Rift detects that one of the links is missing or a box goes missing, it'll inject a more specific into the fabric. So in other words, a P1 is now advertised by alpha as a more specific. And so it'll automatically will attract the traffic for P1. And so another thing which is quite unique for Rift is that it can do unequal path load balancing. And so we solve the problem of having links of different speeds within the fabric. I won't go into the whole algorithm behind it, but you sort of get an idea from the picture here. Another thing which is interesting in Rift is that it has the capability to detect miscabling. So in other words, Rift uses what we call zero-touch provisioning. That's due to that the underlay runs on v6, so using neighbor discovery, that's the foundation of CTP. But it also detects, for example, if switches within one level are not interconnected with each other. And so it can automatically detect those link failures. Another good thing of CTP is that you only need to provision or have to provision the top of the fabric. So all the configuration is done at the top of the fabric. And because of CTP, it detects that nodes are connected and in which layer they are. So another thing is it's an open standard. It's currently being worked on in the Rift working group in IETF. The main contributors are Juniper and Cisco. There are some other interested operators helping out as well. And the latest version, which is revision 11, if I'm correct, is about to go for workgroup last call. So we're getting to a standard there. Again, one of the other advantages, it can operate on asymmetric bandwidth fabrics, detects link failures, and will inject more specifics to work around that. It scales very well multi-level, where if you look at, for example, BGP or ISIS, you will run into scaling issues, especially with the very deep fabrics, 5 or maybe even 7 layers layers deep. So multi-homing servers is something that can easily be done in Rift. For example, if you run a routing stack on the host, it can directly become part of the fabric. And so you can provision whatever overlay tunnels you want to use. So BFD is not, as with BGP and ISIS, an extra protocol you need to run, but a fast rehash and early loss detection is built in Rift, if you want to say. Another thing which is really interesting, it's a minimal blast radius. Again, failures are have to be detected only one level up. As what we just saw, that's the position where you need to inject your more specific in case of a node or link failure. Flooding is around 30% reduction if you compare to ISIS. So that definitely in high traffic and fabrics with lots of nodes, up to thousands of nodes, that really makes a difference. It is by design loop free. So as what we've just seen, Rift will try to utilize all links available as long as they are not detected as miscabling. And let me see. Yeah, so coming back to the standardization, I already touched briefly on that. It's being worked on in IETF in the Rift working group. Co-authors from Cisco, Yandex, Mellanox, and others are working on it. And there are some sort of implementations, either in beta or early releases. There is a package for Junos, which you can install if you run 19.4 R1 or newer. You can download the package, install it, and run Rift. It is also in some of the virtualized or containerized Junos releases. And there's an open source implementation written in Python by Bruno Reisman. And so Bruno and Juniper have done a lot of IO testing as well to make sure that the protocol is built both by Juniper and by Bruno according to what is written in the Rift draft. And so that is it. I'm not sure if I can hear or read any of the questions. Let me quickly go to the chat. Ellen, I'm not sure if there are questions, because I cannot hear you, so maybe you can type them.
So we have a little bit of a sound problem here
Okay,
with this.
so no questions. If there's any questions afterwards, if you want to test Rift, feel free to reach out. I'm based in the Netherlands, but my region is EMEA, so I'm happy to help out. Just drop me an email, melchior@juniper.net. And yeah, let's play around with it. Thanks.
Thank you, Melchior. Excellent. So we have a few minutes. This is incredible. This is the first talk that's not gone over time. The next segment is going to be a little bit awkward because now I actually have to introduce myself. Let's see how we do that. I think I'll just step to the stage and we'll take it from there. Thank you. All right, so first of all, it's really weird standing here on the stage and actually having something to say and just instead of just presenting people. The talk I'm going to do is called Using Network Automation to Replace Pure Documentation. And it's a talk about auto-generating network documentation. It's also a talk about best practices, but not necessarily in relations to each other. It seems a bit weird, but I'm Alan Ising, if you hadn't catched that so far. I work as a network engineer. I work in Telia company in Norway. I have these 3 AS numbers listed here. The talk here is about the middle AS number, but I'm involved in all 3 of these. I have also a blog where I write something about automation once in a while, a Twitter account, and a GitHub with some unfinished code on it. Starting with a disclaimer here, because I'm going to talk about bad documentation. And I mean, everybody can look up this AS number, and maybe somebody knows somebody who once worked with this AS number. And it's really not my intention to put anybody out there or shame anybody or anything. We all who've worked in network operations, we know what time constraints we're working under. We know how hard it is to actually have the time to write proper documentation. And as I'm going to cover later, proper documentation is actually not something that we really do. So with that out of the way. This talk starts with a situation that is common in many larger ISPs and providers, that sometimes we merge with smaller providers, we take over networks, we take with us some engineering staff there, some documentations, and smaller networks have other constraints than bigger networks. They might implement things differently, with less budget, with other standards, or maybe they have more diverse and interesting product portfolio that makes things a bit more custom than we are used to in the big providers. And also there is a culture in big providers that might leave network engineers from smaller providers to say, so long. And then they ride out into the sunset and leave about the documentation. And then you open the documentation and you find a list of resources and network diagrams. And that might look something like this. Then it might be a list of VLANs, a list of IP addresses. It might be in Excel if you're really unlucky. It might be inconsistently filled out. There's usually about 1.5 standard per engineer when it comes to free text documentation. And network diagrams might have been up to date at the time they were created. But the thing is, nothing here actually tells you about how services look. And that leaves us to a very important observation that resources and services are not the same thing. Resources are just that. They are something we can assign. We can have lists of them. They have life cycles. Resources are, for example, IP addresses, route targets, VLANs, service IDs, whatever we have there. They can come from pools. They can have assignment policies that can say something like, if we provision management addresses, we're going to use this network to take them from, or our management service is always VLAN number 100, or something like that. Policies. Services, on the other hand, include resources. They also include connections between these resources. For example, I might have a link IP address here and a VLAN. They belong together on the same physical link. That's not necessarily so easy to read from the documentation. The services, they own these resources. So we have this relationship between the resources and the services. For example, if I take down these services, these resources are now orphaned and need to be cleaned up. The same goes with services. They are owned usually by a product. For example, I might sell an MPLS VPN, I will call it. That in reality is a VRF I'm pushing out here. So that's the product and the services are not necessarily the same either. And then we have them owned by customers or the infrastructure. So what we are left with here is when we just have the resource documentation, the other is just tribal knowledge. And what do I mean with tribal knowledge? I mean that it's the stories we tell each other and the standards we instruct each other in. These might just exist as collective tribal knowledge. So when you start in a new network engineering department, you are able to say, I have this customer here, he's called Bob, what is it about him? And somebody can say, oh yes, by the way, I remember this customer, he has this and this problem, or this and this policy. But this is tribal knowledge, and we're really, really bad at documenting it. So for this particular network, we lost the network engineering staff there. I had some time with them before they left. I got their documentation. But then I was left also with a platform that I didn't particularly know. Their routers were Nokia routers. I've only really worked with Cisco and Juniper in the past. So I not only had to learn a new network, I had to learn a new platform, and I had to learn how these had services in them. And not only that, I also needed to make sure that my colleagues could do the same thing as me, because they might have had less time than me to learn this stuff. So I wanted to make something that was searchable and documented the services, because searchable is easy if you're really good at, for example, grep commands, and you can grep in the oxidized things, and you get a better picture, but that doesn't really work as something you can let everybody do, and it's not documentation either. So my approach was to write a parser for the Nokia SROS, then write a backend to store it in, write a pretty front end, and hopefully profit from it at some point. So my first step was to start writing this parser. That was difficult. That took a few attempts, and as you can see, this is an actual screenshot from the first directory where I started the work. It took a number of very frustrating attempts, but in the end I came through, and it started off with a lot of if statements and regular expressions and not very, very pretty or readable or maintainable code for that matter. But, you know, in the end I got something that looked a little bit better and was easier to work with. And that was what I based it on. But the takeaways here is probably don't do that. probably don't write your own parser. There are good ways of writing parsers if you're really, really good at computer science. There are these frameworks to write them in. They're complicated. They're too complicated for me. And in reality, there are much better ways to doing this. For example, if you have a modern network operating system, you might have Yang models. Yang models are really cool. They're model services and network configuration, and then that saves you the whole parsing thing. If you can't do that, we have things like text FSM, which is a cool way to parse CLI output. Or if you have a Junos device, you can just pipe display JSON or display XML, and you also have everything structured for you. And I'm sure that iOS XR has the same thing. Once I had something parsed, I needed to store it somewhere. And the logical place to store something is something like an inventory, which is basically just a number of SQL databases. But I decided to write this in Django, which is relatively popular these days. So it's easy to get started with, it's easy to write, and it has a really cool thing. It has a database ORM. A lot of systems like this has it, but that gives you the one advantage that you can make mistakes. And you will make a lot of mistakes if you do things like this from the bottom up. For example, a good example of a mistake you could have made, you could have looked at the configuration and you could have made the conclusion that all my route target imports and exports are the same. So why use two different database fields to store this? I can just collapse them. And then you find that one that has the different. So you decide to change this, and this is very easy. You don't need to know any SQL to do this. You can just change things, and Django will help you do the migrations. And then you can. Then another cool thing about Django is the REST framework. That is something that allows you to really easily make APIs for this. And APIs is really essential, I think, if you're going to do any sort of storage of services and data and network information. There are lots of alternatives to Django, and it's really what you feel is the tool for the job and the tool that you can do. There is probably a Django-like system for every programming language that has a reasonable amount of popularity these days. Django is Python. There are other frameworks in Python as well. But this worked really well for me. I had some lessons when I did this, because I'm used to when I do my databases, I put in an ID in every table. It's not necessary to do that. And it's really nice to use natural keys when you can do it. For example, in your network, your host should be unique. If you have two routers called exactly the same, then you have another problem. So your host name can be your key, and that makes updating really a lot easier. You should also be aware of human input errors. This comes back to the whole writing a parser thing, because white spaces can exist whenever you do anything inside of string. And that is something that can happen on this Nokia SROS platform a lot, because interfaces, for example, logical interfaces, are just something you write within two of these nice exclamation, or these quotes here, quotation marks. And that means you could put in whatever you want, including white spaces at the end. And that is something that's going to mess your regular expressions up if you don't catch this. Also, things that should be unique but aren't. It's possible to have two interfaces called exactly the same if one is actually active and the other one is not configured correctly or in shutdown or not attached to a physical interface. And that's also something that's really hard to do in a line-by-line parser, because then you come into sort of these conditions where you override a running interface with something that was shut down because the VRF is numerically lower down in the configuration. Really, really hard to solve. The easy way to solve it is, of course, clean up your network, but that's not always something you can be 100% certain happens before you run the parser. So I started this, and it sounds like a lot of complicated work, but I did this in stages, and the first stage was already 100% usable, because it was just a matter of taking a manual configuration file from the router, putting it into the parser, and directly populating it into the database. And whenever I had to update this, I just deleted the node and re-imported it again. So I didn't have to take care of updating any objects. I just started from scratch every time. and it's quite easy to have something. I mean, if the goal is just you need to be able to search for a description, well, that's a few lines of Python. That's really easy. Services, it's also easy to index services. It doesn't have to be very complicated. So the next stage of the development was to have this a little bit more automatic. I needed configuration backup. Everybody does that. We use Oxidized for this. So I plugged in Oxidized, and Oxidized has a REST API, so you can just go in and see which nodes are in Oxidized, give me the configuration, it works. Still, the parser runs inside the Django application. Everything is inside of this application. Then I got the crazy idea to rewrite the front end. But I think that's something you can do and should do if your goal is to have something that is very easy and very fluent to work with. And I wanted to take the view out and have it as an external component, both because I wanted to write an IPAM that I won't talk any more about because that didn't work very well. But having it external allowed me to have a much more smooth UI experience, and it forced me to write the API. And now the architecture looks like this, and it's actually pretty cool now. I have the front end completely separate. I have the synchronization engine completely separate, and it listens to Oxidized and checks whether a node has changed, and it just synchronizes those changes. And the Django application is now just an API. So this comes back to something that struck me when I listened to the talk, the other automation talk from Webcom, is that these are two completely different ways of handling the source of truth for your network. In this picture here, I don't trust my documentation. I want to use the network as a source of truth. You can do the other thing, but then you have to be very, very certain that everything that is in your documentation is always correct. And you need to be prepared to override your network completely with your documentation. I don't think many networks are at that point. I congratulate every network that is. In this case, it absolutely wasn't. So it's not a provisioning system. It maybe can be that at some point, but it's an excellent reference that can be used to show what is in the source of truth. It's impossible to do demos here, unfortunately, but I've put out the tool on the internet. It's loaded up with bogus example data and using only like a quarter of the functionality in there. So, but you're absolutely welcome to type this into your browser and toy around with it. There's no customer sensitive data in it whatsoever because everything is generated for this. And I will probably take it down tomorrow or the day after. So the front end looks like this. It's quite clean. It uses Google's material design framework. It has very few functionalities. It has nodes, VRFs, layer 2 VPNs, and the IPAM that we won't talk about. So it's written in something called Vue, which is a JavaScript framework. I'm using pre-made UI components. That makes it super easy to do these styling things. It interacts with the backend through REST. The thing about using a JavaScript framework and using these UI components means that I can be 100% certain that it will load on my phone as well. Not that this isn't necessarily a target, but it's much more flexible. It has an overview of each node. You can click into a node and you can see the ports, lags, interfaces, routing information, and drill down on that as well. You can see what services are in the network. And when you click on a service, you get a nice diagram. And that was one of the goals of the system, to be able to generate this diagram. It might seem like a trivial thing, but being able to go to a network you don't know, you need to look up this customer because this customer has created a ticket or called in. Then you go and you search for the customer, you find his VRF, you get a diagram of how he's connected. That has a lot of value for anybody who's working in operations here. The diagrams are ordered with a box per side. It's the router and their interface. I'm using a library called Dagra D3. It wasn't terribly complicated to write. I was pleasantly surprised. You can drill down to BTP configs, for example, see the prefix lists and the policies, both on a per group and a per peer level. It gets a little bit more complicated when we come to layer 2 VPNs, because layer 2 VPNs can have really strange and intricate connectivity scenarios with their pseudo wires together. Especially if it's not a full mesh of pseudo wires, then the diagrams will be extremely hard to read. But you can zoom and do stuff that makes it a little bit easier. And I really think that this is a level that I would assign as good enough. There's always ways you can improve these things, but this is good enough for an operational day-to-day job. And searching. Searching is also key here. I need to be able to look up an IP address if a customer complains. And I can also type in whatever text description I want to search for. But one of the cool things I can do is I can pull up a report of a supernet and see which individual addresses are in use in the network. So in this example, it's not as interesting to look at because I've just filled in example data, so it's very uniform. But if I type in whatever supernet I want to search for, I get a report of all the resources that are configured this. Obviously, it's not live data, it's only like interface addresses, prefix lists, and static routes. I'm not pulling any route tables from the routers at the moment. So again, you don't have to do it this way. You don't have to have a GUI as a standalone thing. It's become a relatively easy code base to maintain because I have. Oh.
You want any compliments for being good at standing still and being quiet?
Shit, that's not often that happens.
And I have a whole bunch of questions lined up for you
for
when you're done.
Yeah. Can we get a confirmation on whether the stream works at all? Okay.
Yes.
Good. No, I had this this night job where I had to change the MTU of a port and then go through all the VRFs configured in that port, which was a lot, and specify the IP MTU of every sub interface there. And that could be achieved with this few lines of code. And that's one of the key things here, that if you collect data about your network, make it available, because this is operational information that everybody in operations are going to appreciate and will be extremely useful in any sort of migrational or change scenario. So, jumping to conclusions here, it is possible to create service documentation automatically. At least I think that was achieved here. It can be done a lot simpler than I've done here. But as I said, with the individual phases I went through, you don't have to wait until you have this mega modular application. You can start simple and have something that works. So this tool has become extremely useful, and I can't open source anything right now, but I'm working on doing that because I think a lot of this is extremely handy. There are some things that has a lot of assumptions on how your network looks. But I mean, the parser is cool. The synchronization engine I've written that takes a Python object and synchronizes toward a foreign REST service is also pretty cool. Maybe somebody can also teach me to be better at stuff. So I hope I haven't rushed too much through this. I haven't checked the clock, so I don't know how much time I've spent. But absolutely take some questions. That's a record.
Cool, because there are some questions. Starting with the first one from Martin Willems Christiansen. Question: if it becomes a provisioning system, wouldn't it then become the source of truth instead of the network?
Yeah, that's an interesting point. No, no is the short answer, because the part that will be needed for just basic provisioning is just number assignment here. And number assignment is still just resource documentation, and it's not necessarily enough to define the whole network. It's also true if you can regenerate the whole network configuration from it. You can still have a network provisioning system that is not the source of truth for your network.
Okay, next one from Jan Krillesen. Did you at some point consider using SNMP for obtaining the configuration services from the router instead of parsing the config?
No, and there's a really good reason for that. The first versions did not have access to the routers. I had to go to one jump server, load in the configuration by hand, and then paste it over to the system. So parsing was the only option I had in the beginning.
Final question from Veit. Question: do you plan on adding more parsers, information providers? Generally, is extensibility a goal, or is this intended as a specialized tool for your use case?
It's not intended as being platform specific. And that's one of the reasons that I took out the synchronization engine. Let's see if I can find that. Yeah. So the sync application here uses my parser as a third-party package. And the object structure is not very foreign when you look at it compared to the network. So it's absolutely possible to use any other tool for that. And one of my early versions actually had an integration with Cisco NSO as well. So it is entirely possible to do whatever there.
Yes, I have a final question. Christian here. You have 11 minutes left. Can we please hear more how embarrassingly wrong and how it failed your IPAM system?
It's not as bad as I made it sound here. It's just not very finished. That's the thing about it. The whole thing about maybe I can actually, because no, I probably wouldn't want to do that. The thing about the IPAM part is that that was the one that triggered the rewrite, and you can probably click around in the IPAM. It should sort of work. But it triggered the rewrite because this Viewdify diagram or Viewdify framework that I'm using has a tree view that allows for asynchronous loading, which is really handy because the network I took over here had an IPAM that was thousands of lines in Excel. So I needed a way to structure this somehow and wrap it in. And if I generated the whole tree in Django and Django templates, my browser would crash. So I needed a way to be able to have a recursive tree lookup that would just print the subnet I was clicking on. And that was the reason I rewrote it in this JavaScript frontend. And that succeeded, but it's just unfinished. That's basically it. I need pool functionality. I need consistent adding of subnets and stuff like that. And it's not really working right now, but in the future.
Okay, thanks. Looking forward for the 2.0 version next year.
Sure. All right. Thank you very much. And the next one up stage is Julia, so I'm just going to find her presentation.
Thank you so much for speaking.
The 16:9 version didn't come through, did it? The 16:9 version didn't come through, did it? Can I fire up a web browser? No, that's not one. Okay, where's colon on this keyboard? No?
Modern technology, auto-scaling to fit the monitor size. So, I'm here to talk to you about diversity, the dreaded D word. So, we hear a lot of people talking about building diverse teams, and they give various buzzword compliant sort of justifications for why they think that we should have them. They talk about things like plurality of ideas, but I find the best way to explain why we should have diverse teams is what happens when we don't have diverse teams. So some of you will remember the videos that did the round of a soap dispenser installed at Facebook HQ. And it was built by a company called Technical Concepts. And if you were Caucasian, you put your hand under and it gave you soap. If you were a person of color, you put your hand under and it did nothing. They managed to produce a racist soap dispenser. If they'd had one person of color on their team, they would have got this earlier. Apple rolled out a comprehensive health tracker. This could track all sorts of different aspects of your health. Your temperature, your copper content, your calories burnt, calories taken in, but it couldn't deal with menstrual cycles. Women are 51% of the population. A comprehensive health tracker that doesn't do menstrual cycle. Now Google, they trained an AI to classify photos. And one day, a guy took a picture of his family, plugged it into the AI, and it came up with a picture of his wife and said, gorilla. Now, the interesting thing here isn't so much that they found a fix for this, but the way they did it. They removed gorilla as a category. They didn't retrain the AI, they just got rid of gorilla as an option. Amazon got themselves an AI to sort through CVs and resumes for prospective recruits. And no matter what you did, it would only ever select men. In fact, it was so bad that if you had the word woman on your CV, it would automatically deselect you. You played in a women's football team? Automatic deselect. You like watching women's basketball? Automatic deselect. It's not just related to the IT market. There are other cases. A certain Swedish car company, they designed a 3-point seatbelt, which you'll find in every single car. And yet, there was not a single woman on the team that invented it at Volvo. In the event of an accident, the injuries to women in cars is disproportionate to that of men. Injuries to pregnant women in cars are even worse, all because there was not a woman on the team. So, we've identified the problem. How do we fix it? So, it starts with recruitment. I don't know if any of you have had the misfortune of going through the IT recruitment process recently, but it is an absolute horror show. We tend to take a one-size-fits-all approach, and that is fundamentally flawed. To illustrate this, I would like to introduce you to some interesting women. Now, this is Lael Wilcox. Lael Wilcox raced across America in the Trans Am bike race, 6,500 kilometers. She was the first woman to win the race outright, beating not just all the other women, but all of the men. Sarah Hammond. She won the Race to the Rock, a 3,000-kilometre bike race from the edge of Australia to Uluru, the big red rock in the middle. The first year she did it, she was the only woman, or in fact the only person, to finish. It became known as the race so hard no man has ever finished it. The following year, she won again. A guy did actually manage to finish that year, so it was now the race so hard no man has ever won it. And then she came back a third year just to prove a point. And then Fiona Kolbinger. Last year, she won the transcontinental race. 4,000 kilometres across Europe in 10 days, 2 hours, 50-something minutes. She beat 225 men and 39 women. These are just some cases I picked from cycling. I'm a cyclist, so I knew to pick them. But there are also other cases in ultra running. Yasmin Paris won the spine race, breaking the record by over 12 hours, coming in considerably ahead of the first guy behind her. The longer the race, the longer the event, the more likely women are to be able to beat the men. We're not going to win at the 100-metre sprint, but 4,000 kilometres, we've got a good chance. Or put it another way, don't judge a fish by its ability to climb a tree. So why then do we judge everybody the same when we do our job interviews? Why do we judge them the same when it comes to our job adverts? Now, a study by HP found that men will apply for a job when they meet 60% of the requirements, whereas women will only apply when they meet 100%. So when you have a job advert that lists a whole string of requirements, or just a whole string of it would be nice to have, when actually the reality is you don't need all of those. And so your advert is automatically putting women off by just including stuff that's not necessary. Ideally, for our industry, a network engineer, your job advert looks like that. You want someone with a degree or equivalent experience. Never underestimate the people that have skipped the academic route and learnt the hard way. You want someone that can communicate well, written, spoken, whatever languages your company uses. It would be nice if they've got some experience. And then you want them to be a team player. Now, the original first draft of this slides, that last bullet point was not an arsehole, because that's ultimately what we mean when we say team player. But I had to get it past a call for papers, so I changed it. But when we list all of the things that we typically do on job adverts, the tools that we are using today are not the tools that we used 5 years ago. And they're not the tools that we'll be using in 5 years' time. So why are we listing, at a point in time, these very specific items that are just putting people off? So, having put our job interview out, a job advert out, having got lots of women, lots of men hopefully applying for it, it's time to look at the interview. Now, think about what your interview needs to achieve, and think about how much of an interview you need to do. I have not applied to companies when I discovered that they had an interview day that involved 4 separate interviews and going for lunch with the team. That's just too much stress for most people. What are those 4 interviews actually adding on top of each other? I was talking to someone recently who went for a job interview with one of the big evil empires. They had 7 interviews in one day. And in every single interview, every single one of 7, they got asked the same question. Why do you want this job? Why are we putting people through that? Also consider what time of day you're offering your interviews. Not everybody has the luxury that they can duck out of their existing job to come along at 10 o'clock on a Monday morning to an interview with you. They might have childcare commitments. They might have a boss that they're trying to get away from that won't let them have the time off. Offer the option of a Tuesday evening. offer potentially the option of coming in on a weekend. You're about to commit to a relationship with somebody, which hopefully is going to last 5, 10, 20 years. Your company is going to invest tens of thousands, if not hundreds of thousands, in this person. Going the extra little bit to come in on an evening or a weekend, or just offer flexibility. When you send out your invite, include all of the accessibility information in the invite. Don't make it so that somebody has to say, I'm sorry, I'm in a wheelchair, I need access arrangements, or what are your large print or braille arrangements? Look at all of these things and just provide them straight off so people don't have to ask. When you're in the interview, think, is your question really necessary? Hands up, those of you in the room, if you've had the question, what is your biggest flaw? Now, hands up if you answered that honestly. No one's giving an honest answer to it, so what is the actual point in asking it? The other pet hate, whiteboarding. Women are conditioned from an early age not to stand up, not to put your hand up, not to go in front of the class, not to speak out. Be seen but not heard. So for many, when you give them a whiteboard marker and say, stand up in front of this whiteboard and write your answer, that is petrifying. For many people, if you gave them the choice of that or a trip to the dentist, they would have to think about which of those two they choose. We are disadvantaging 51% of the population by including needless exercises like that. There are alternatives. Consider, just put a sheet of paper on the desk. Let's work through this together. It's a much more friendly, much easier environment to work with. So, when you've done your interview, let your candidates know in a timely fashion. Don't have it that they have to wait 2, 3, 4 weeks to find out whether or not they were successful. They might have other jobs they've applied for. They might be waiting to find out whether you want them before they will actually say yes to something else. For every candidate you interview, even the ones that you don't hire, provide feedback. We loved what you did. We loved the answers you gave, but we think it would be good if your knowledge was a bit stronger in this area. Give constructive feedback. So, you've interviewed them, you've offered them a job, and they've said yes. Now, I've spoken to many directors of various companies over the years, and a phrase that I hear time and time again is, I love hiring women. We hire them all the time, but they just never stick around. And that is a big red flag, because what that means is the culture and the environment of my company is so awful, women don't want to stay here. It's a toxic environment. So, how do we fix this? Step 1, and I can't believe I'm saying this in 2020. Equal pay for equal work. If you have 2 network engineers doing the same job, regardless of the fact that one of them's a guy and one's a girl, you pay them the same. No ifs, no buts. In order to ensure this, you need pay transparency. I'm not suggesting that we should be listing that Jane earns this much and John earns that much, but what you can do is you can say, in this team, we have 4 people that earn between 3,000 and 3,500. We have 5 people that earn between 3,500 and 4,000. We have 1 person that earns 4,000 to 4,500. People can look at that. They can look at where they are. They know what's on their pay packet, and they can go, wait a minute, there's 1 person who's earning a lot here. Why am I in the bottom bracket? They can then talk to people. Now, when I wrote these slides, it was for a presentation in a different country, and their parental leave is nowhere near as good as that in Denmark. And at risk of getting lynched, considering where I am, Denmark's is nowhere near as good as Sweden's. And Sweden's is not as good as Finland. But all of Fennoscania has considerably better than many places. So even though your country might not offer great maternity leave or great paternity leave, your company should offer equal parental leave to both parents and offer it regardless of how the baby arrives, whether it's through bureaucracy or conception, i.e. adoption versus actually giving birth. One of the arguments a lot of managers give is, I'd love to hire women, but they're going to go off and make babies. Well, if fathers are going off and having the same amount of parental leave, that argument's completely null and void. As part of this, also, offer flexible working hours. We have an industry where, by and large, we can do it from anywhere in the world. We're proving that at the moment with the current medical crisis that is, people are working from home. People are proving that they can work flexible hours. And yet, as an industry, we are concentrated on a 10 square mile area in an earthquake zone. We don't need to be. Offer flexibility. This is actually one of the areas where the Dutch are great. If you have a child, you have a right to request a 4-day working week, and your employer is required to give it to you. No ifs, no buts. We don't need to work a 40-hour working week anymore. Offer people flexibility. So, let's talk about the working environment. I appreciate that I am a native English speaker standing in a foreign language talking to people about what is often their second, third, or even fifth language. But please don't use females to refer to women. When you do it, you sound like a Ferengi out of Star Trek. Some languages, they do have a differentiation between women and females. German and Dutch, I believe, differentiate. My limited linguistic research suggests Danish doesn't have this problem. But yeah, I was talking to one conference organizer and they about the fact that they didn't have any women speaking, and their reply was, we'd love to have females speak, but no females apply. It's like, well, step one, the word you're looking for is women. Step two, I'll do it. That's how I ended up here. Now, another linguistic issue. Guys is not the gender-neutral term that you think it is. And if you think it is a gender-neutral term, I have one very simple question for you. How many guys have you dated? Find a better term. Folks, people, colleagues, minions, find something that is gender-neutral and is not automatically disenfranchising part of your team. We've had a lot of talks today about documentation. When you write your documentation, avoid the default male. Either write it in gender neutral or change so that you refer to she, he, alternate it. Look at the different ways and beware your linguistic biases. With the culture of your company, be very, very careful with microaggressions. They might seem like very small things, but they all add up. You need to take a zero-tolerance attitude to negative behavior. There's a big myth within the IT industry of the 10 times engineer. The person so valuable that, yes, you know they're an arsehole, yes, they keep pissing everybody off, but we can't possibly fire them, they're too valuable. That's called a single point of failure. What happens if they get hit by a bus? If you can't fire them because when they're an arsehole, you shouldn't have them in the first place. When your employees come to you and say, I'm having a problem with X, or they come and say, colleague so-and-so is making misogynistic comments, believe them. You only need to look at the news to see that that is much, much cheaper in the long run. I appreciate that I'm talking generally here to engineers, not managers, and not HR departments. But if you like the ideas here, take them back and get buy-in from your managers. You can change the way your company is run and the way the culture works from the ground up. And the other thing there is monitor the way, the churn rate that your company has. Yes, you're hiring 20 women every year, but none of them actually survive in the company more than 6 months. But you don't know that unless you actually monitor and have statistics on it. So, having recruited people and having retained people, we need to keep the pipe flowing. Your companies need to invest in educational outreach, whether that is through hackathons, whether that is through supporting open source projects, or working on projects with local universities and colleges and schools. Offer paid internships. The key word there, paid. Get involved in the graduate schemes. There are various different events in different countries to encourage more people from minorities to come into our industry. In the UK, we had things like Take Your Daughters to Work Day. There must be something similar where you come from. Support them. So, any questions?
There was one question, just for a clarification, if you could define microaggressions, please.
Okay, en.wikipedia.org/wiki/microaggressions is the very short answer. The best example is when you turn around to somebody and say, "You've got very good English." That's a microaggression. There's lots of different ones, and it's a facetious answer, but the Wikipedia article does explain it better than I ever could. But it's these little things that they all add up. Oh, didn't you do well for a girl? So, yeah. Any more questions?
Doesn't seem to be the case.
Cool.
All right. But thank you very much for coming and talking here. All right, we've reached the end, which is pretty amazing in many ways. I mean, everything taken into considerations. This one is not the slide I want to show. All right, so despite a rather unfortunate standing point for this event, we've had a really good day, I think. It's been really weird sitting in this room and, you know, having hundreds of people at some points, sometimes a little bit less than that, watching the stream, where we expected to have our biggest event ever with 223 participants and people nearly not being able to sit in chairs in here. But I really want to thank all of you who have listened into the streams, all of you who have traveled and stayed with us at the hotel, everybody who signed up, everybody who supported us through this day. It's been a real pleasure to do this despite all the odds. And I would especially like to thank our sponsors who made this event possible and still make this event possible for that we can sit here in this room and still have a conference. It's pretty amazing. I'm really sad that we can't now go into the buses that would have been waiting for us outside and go to Teaterkælderen, where we would have a rocking social. I hope some of the people here in the hotel will stay around for maybe a drink or two in the hotel bar afterwards. That'd be very nice. Unfortunately, I can't invite anybody outside from to join in because of the situation. But again, thank you all. And there's a few things I'd like to say. We will be putting up, and there should be some surveys already up there now, but they're not matching what's been presented today, unfortunately. They were all pre-scheduled, so they were the surveys for whatever should have been in the programs are up now. I will put everything up and remove everything that haven't been said. So please rate the talks. It's hard to do this completely fair since some of you have seen presentations live, some of them have seen them through streaming with technical hiccups, some have presented remotely, which also makes it for a different experience. But please rate the talks as well as you can, so that everybody who has presented can learn and grow and become better speakers. If you are here in the room, we have a bunch of hoodies. We have 200 hoodies. Take one with you when you leave. For those who wish they had a hoodie, we will figure out something. I cannot promise you what it will be. We have discussed whether we can have an event in half a year, which will be not a conference like this, but something with content and something with a social, which could be an opportunity for you to get those hoodies that you deserve for attending this conference in whatever way you did it. So again, there's also going to be a general survey. It's not going to be completely accurate because of the circumstances, but give us whatever feedback we can. These are strange and interesting times, and we hope that this will be the last DKNOG that will be virtual only. So again, thank you for coming.